Okay, good morning, everyone. Welcome to the second day of the Slices workshop. Thanks for the very nice attendance and interactions we had yesterday. It was very, very interesting. So let's keep the pace today. Today we have a very, very tight schedule. I'm happy to be the chair of the first session on the scientific challenges. We have four great speakers, Professor Ari Pottu, Professor Paola Grosso, Professor Jörg Ott, and Dr. Dario Rossi. So we are running on a very, very tight schedule. So I apologize to the speaker already, but I will have to be tight on time. So you have 15 minutes each. If we extend longer than that, I will have to cut your presentation. So please try to be on time. So let's start immediately. The first talk is given by Professor Ari Pottu, who has a scientific and engineering experience as a researcher, project manager, and research manager in various domains of ICT development, including military radio communication, radar system, embedded device networks, cellular systems, and others. He has published more than 70 papers in the field of wireless communication. And he was the director of the Center for Wireless Communication at the University of Aarhus until 2012. Now he is working on dependable wireless solutions for verticals such as energy, industry, health, and automotive. And he is the vice director of the national Finnish 6G flagship program, which is one of the first research programs in 6G that has been launched. So we are very, very happy to have Ari on board for this event. Thanks a lot for joining us, and the stage is yours.
Yes, thank you very much. And
we hear you very, very low. I don't know if it's only me.
Let me try to fix the microphone.
Yes, it's a little bit better now. Thank you, Ari.
Thank you. And I should be able to share, right?
Yeah, if you share, there is a share button at the bottom.
Yes.
And you can share the screen and then choose the window you want to share.
Can you see my slides now?
Not yet. We still see you. If you prefer, Stavroula can share them on your behalf, and you can talk.
Application window.
Right. If you have the application in the same window as the browser, you should see it.
I have two PowerPoint presentations open, so I should close the other one. It appears I cannot share. There are some problems.
Okay. Then I propose that Stavroula shares the slides on your behalf, and you talk on top of that.
Thank you.
Stavroula, can you do it, please?
Give me a minute. Ari, have you sent your presentation? I cannot find it.
I sent it yesterday.
Yeah. I'll find it. Don't worry.
It complained something about authorization issues with the operating system, so I couldn't share.
Okay, Ari, I will do it for you. So just let me know when you want that I change the slide, and you can go.
Now it seems I have lost also the the window. I can't see now even the window. No, now it's back. Thank you very much. Okay, ladies and gentlemen, my name is Ari Pouttu. I work here at the University of Oulu in Finland, and I have a presentation for you. I have 14 minutes left, so I will try to be really quick. But the title of my talk is On the Road to 6G. First of all, what is the world that we expect to see in 2030? Now, we have been stating in the 5G that we will connect processes, machines, and digitize the whole society by using the technologies offered by 5G. Some of this will already happen during 5G, but not all. And when the processes and machines, all those are connected to internet, we start to see a huge emergence of data from dynamic processes. And here the wireless connectivity becomes important, together with machine learning algorithms and solutions that can actually offer dynamic data on dynamic processes and decision-making support. So our society will be data-driven, and it will be enabled by near-instant unlimited wireless connectivity. Now, if we go into the world's first 6G research program, Stavrula, if you could roll down a little bit there. So in 2018, the Finnish government launched, well, actually at 2017, Finnish government launched a flagship program where they were looking for spearhead projects within the Finnish scientific community. And we submitted our proposal, and our proposal was successful, and it became ranked #1 in this competition. The program itself is an 8-year program with an estimated volume of 250 million euros. Obviously, this is not all coming from Academy of Finland and the university, but huge amount of this is estimated funding, which is then received from different competitive sources and with collaboration with companies and, for instance, the Horizon Europe funding programs. This flagship is operated by University of Oulu, and we are doing this in strong collaboration, obviously, with Nokia, but also with VTT, Aalto University, Business Oulu, and Oulu University of Applied Sciences. And we do have a lot of other companies which have joined our activities as co-creators, companies such as, for instance, Keysight and InterDigital. We have 3 high-level general goals. First of all, try to introduce this 5G to marketplace, and this happens by having projects offered for players in the vertical industries, may it be industry, factory, or it could be health, it could be sports stadium, it could be a shopping mall, it could be transport, for instance, ports, it could be railroads. So offering this 5G capabilities to vertical business areas where it currently doesn't exist. So this is the first general goal. The second general goal is really look into the fundamentals of 6G technologies and develop them. And the third goal obviously is to speed up the digitalization of society, which basically is an outcome of these 2 first general goals. The research program is divided currently into 4 basic research areas. First of all, there is this wireless connectivity. Here we look at the technology enablers that can actually offer us tools to enable unmanned processes and connecting everything into the internet. And this is basically targeting for short-range communications up data rates up to 1 terabit per second. But on the other hand, for not so high data rates, you might need ultra reliable and extremely low latency communications. Industries are aspiring for control loops that may be 2000 hertz, which already states that we need to go down to 100 microsecond air interface latencies in order to offer this 250 millisecond end-to-end latency for providing these kind of control capabilities. Now, if we think about this 1 terabit per second, it basically means that we need to go high in the frequency. And this gives rise to second research areas, the devices and circuits. Now, if we think about the current semiconductor technologies and how far they can efficiently go, we start to see problems arising close to 100 gigahertz frequencies. And if we want to really push for this 1 terabit per second data range, we really have to go beyond this 100 gigahertz, which means that we need to find new semiconductor materials, new ways to design circuits, new ways to build antennas, and this is a huge undertaking, which of course a program like ours can only make a small dent. And here we invite the big semiconductor companies to join the effort. Third area obviously is important, distributed computing. We already talked about this low latency issue, and then there is obviously the security side of things where distributed computing becomes very attractive. So we wish to complement this cloud-centric approach with this edge computing approach, and include there also these novel emerging machine learning type of algorithms that could offer decision support for processes and self-driving vehicles and many other things. But now we must understand one thing, is that we cannot anymore rely on the traditional machine learning algorithms where we have hours or days or even weeks to chunk and try to figure out what the data contains. Now we are talking about extremely dynamic processes, and therefore the machine learning algorithms need to find for this dynamic phenomena has to be totally different from traditional ones. Third area is these services and applications where we look at, for instance, disruptive value networks. One of the ideas that we've been strongly pushing is this micro operator type of players entering the market to complement the offerings of the mobile network operators. We start to see divergence of networking technologies required by different verticals. Let's take, for instance, agriculture or industrial plant. In industrial plant, the density of the network might be huge. On the other hand, in the agriculture, the density is low. Then, on the other hand, if you take a look at, for instance, the latency requirement, then the latency requirement is very strong for instance, in a factory. But then again, in agriculture, it's not so tough requirement. Now, this actually calls for specific players that know the vertical very well and can adapt the offerings of ICT portfolio to in a tailored way to offer extremely good services for a vertical player, and thus new players may appear. Now, if we go to the next slide and look at the some of the numbers that we have so far reached in this program. Currently, we have already more than 305. We are close to 400 people that have been at some point working in this 6G flagship. The publication numbers are currently more than 1,300. and the research project number is close to 300 nowadays, and we have 136 new company collaborators attending this 6G flagship program. There is also a slide on the right-hand side of the slide. There is this 5G TN, but I will not dwell time here. I have a couple of slides later on. Now, if we go to the next slide, one of the things why I say that 5G and 6G should be treated as one continuum is the fact that the history has already thought that the value chains actually seem to be reformed every 20 years, even though we are introducing new cellular generation in every 10 years. 1G and 2G basically brought voice connectivity between peoples, but it took 20 years. And then 3G promised already internet our pockets, but actually it provided only email. 4G provided internet in our pocket. 5G will start the transitioning towards the internet of things. And I would bet my money on the fact that it takes more than 10 years, and during the 6G era we will start to see really trillions of connected objects and intelligence introduced into the computing platforms near the processes. Next slide, please. So there are several critical drivers towards 6G. I have listed here some. There are societal issues that we need to really take a new good look at when we go towards the future. And one of them is the United Nations Sustainable Development Goals. But the other one is also the needs of the digital society. So we need to bring down the costs of the societies providing different kind of services. Then on the business side, we start to see, first of all, these disruptive new business models where new players start to emerge in the market. But on the other hand, it's still all about productivity increase, and we need to also take into account the fact that what the verticals actually need, not push, but actually ask what they need. Data privacy and security. The number of threat vectors in 5G already exploded, but when we go into the 6G world, this will still emerge in big numbers. First of all, because of these new players coming into the market. For until now, we have trusted our mobile network operators beyond any doubt, and that is basically because they have been basically a lot of regulations and rules and even laws that basically put them in such a place that they need to be really reliant. But in the new world, when a lot of smaller players start to appear, the security issue becomes again a new, well, it's not a new, but even a more bigger problem. I already talked about the radio tech and AI, not dwelling there any time, but one of the things that we do hope and really push for is this global collaboration and standards. One of the things, even with the geopolitical pressure ongoing, we still push heavily for global standards, but with the extra spice and flavor that we really need to involve the vertical players to tell us what are the real requirements stemming from their applications and what they want to do.
Ari, sorry, you have 1 minute left.
Okay, thank you very much. So let's go through the couple of slides, just skip them. The playground is obvious. You can see that we have 12 different areas of research that we have been doing, but since this is a slices workshop, I'm telling you something about our test network. So here you can see what we have done in the past and what we plan to do in the future with our 5G test network. This basically is a private network, or we are a micro operator that has capabilities from 4G to 5G new radio. Now we are introducing millimeter wave and cloud run radios. We have the first sub-terahertz research infrastructures coming in near future, and start to look at, for instance, 6G waveform generation and these kind of issues. On the networking side, we see the evolution towards extreme softwareization going all the way down to vertical specific or even user-centric network tailoring. On the next slide, we see a couple of things about what needs to also be taken into account is that when we go into the 6G era, there are a lot of regulative and legislative issues that we really need to tackle in order for this new world to happen. And this is also something that we look at. And obviously, the scientific research teams are there. So without further ado, I thank you and conclude my presentation here.
Okay, thanks a lot, Ari. Very, very nice. Apologies for the short time we could allocate.
No worries.
Interesting. We actually concentrate all the questions at the end of the session. I know you have other commitments, but if you can try to be back with us before the break, meaning around 10:05, that would be great.
Unfortunately, I cannot come back. I have to. I have a presentation and a panel discussion coming up.
Sure, don't worry. So
this Parliament EU Renew Europe session, so it takes the next 2 hours. Unfortunately,
okay, don't worry. So any burning questions, please email him. He's very available, so he would be getting back in touch with us and with everyone else. Thanks again, Ari.
Thank you very much, Andrea.
So let's move to Paula's presentation.
Yes.
So we are very happy having Paula on board. She is an associate professor at the Institute for Informatics at the University of Amsterdam, where she leads the multi-scale networked system group, which researches the emerging architectures that can support the operations of multi-scale systems across the future internet. Paula has an extensive record of contributions to international projects, and she is currently involved with our group in numerous EU-funded projects, among which GN43 and FED45+. So it's really a pleasure, Paula, having you with us. The stage is yours.
Thank you very much.
15 minutes.
Thank you very much. I know you're very strict, so I will stay in the 15 minutes. I hope you can see my slides, because now yes. I only see my full screen, so I don't see anything any longer.
We do see your slides.
Very good. Then I will just get going to be able to use efficiently my time. You already introduced me, so I will not say anything about myself. I will just very briefly say who do I talk today, on whom behalf I talk today. I talk today on behalf of an entire cluster of research, which is present at the University of Amsterdam, which is the Systems and Network Engineering Research Cluster. And I myself indeed lead one of the 4 groups part of this cluster. But today I talk a little bit about on behalf of all of us, and I will take a perspective of a computer scientist that tries to do research in a research infrastructure like the one that we are developing in this project, and we are researching in this project. Now, I will come from a computer science perspective, like a user perspective, into slices. Now, what are the scientific challenges? I was asked to actually make you think of what are the things that challenge us as computer scientists and as developer of infrastructures. And I think this is something I would like to discuss with some of you maybe in the break, is that I think we see a movement clearly to put the user at the center. So letting the user decide what happens with her data. So effectively empowering the user of the infrastructure. And the question that could be made to you is, who is the user? Who are you targeting this control for? Is the user the individual, or is the user an application, is an organization? I will get back to that later on. If you take this perspective that you want to put the user in charge, then the thing that you want to do as computer science is to research what are the methods to be able to exchange the data between parties, between users, so that you can achieve a common goal and maybe potentially also compete, but cooperate. And effectively, the question that in the research infrastructure you need to be able at a certain point to implement and to answer is how you control, how you to keep control on data algorithms so that you can actually use them according to the agreed purposes. So this is a bit the time, let's say the framework in which I want to bring the discussion. Now I will go very briefly through these 2 slides. Is that nowadays you see that there is an enormous amount of large experimental facilities, scientific facilities where there is exchange of data across research infrastructure for scientific purposes. And at the same time, we have a lot of data being exchanged nowadays between organizations to accomplish societal use cases. Now, here I mentioned 3 projects for which I will give you the link at the end, in which we are as university involved too. And they have to do with personalized medicine, which is going to become more and more a theme of research in the coming years. So effectively, lots of machine learning, lots of technologies to be able to provide individual feedback to patients, tailored to their own specific person, but also lots of industrial and business use cases, again, where data needs to be shared between companies, example for logistic purposes, or smart cities development, which I'm pretty sure here in the audience, many of you are involved with. So there is lots of data that needs to move around, and you still have in the background the fact that you want to allow the user or the application to be able to control what's happening. And the problem you face when you actually are trying to use this type of infrastructure or design the type of infrastructure is that you have a triad that you have to actually keep always in mind, that you have the data, you have algorithms, and you have resources, and they are not necessarily located in the same place. So the whole discussion of cloud computing that we have been having a long time, but also in this context, yesterday I saw some more talks about it, fog computing. So where you distribute the computation, where the computation should go, and how does it relate to the location of the data? Now, if data, particularly like in these slides, comes from different organizations and it needs to move where the algorithm developers are centered, you have all kind of technical issues to address. So this is one of the challenges we computer scientists see need to be tackled by slices research infrastructure. Now, here I will zoom a little bit into a possible scenario. Let's think again of personalized medicine. So in personalized medicine, very often you have data coming from multiple hospitals because the patient has been treated at multiple locations, maybe by his general practitioner, but also then later on, maybe in a hospital setting. And there is need to do some kind of machine learning for the specific user, still privacy preserving, and this is another topic that we could discuss extensively, but still the data needs to move around across multiple infrastructures, and you have to be able to discover where the data is, you have to be able to correlate it, and I will actually spend a bit of time here to talk about auditing. So auditing purposes, when you put the user at the center, will be something that will need to be addressed by this type of infrastructure we provide. Now, our answer in our university is to think of digital data marketplaces. So this is a picture that expresses the kind of architecture we are trying to test and build. The idea is that you have indeed agreement between parties, and these agreements also reflect laws and regulations of the specific countries the person is located. And you have, as I said before, this triad of algorithm supplier, data supplier, the customers, and the infrastructure itself, where you actually try to deploy the data sharing. So I have very limited time today, it's a very short talk, but if any of you is interested to know more, we have already published quite a lot on this topic, and we are actually experimenting in this area. So I will give you a pointer later on. So secure digital marketplaces is something we would like to test in research infrastructure, and some of the technologies and components are generally applicable, as I said before, in scientific use cases or in societal or business application. Now, I go back to this concept of auditing, which is something that I also would like maybe in the future moment of Q&A to be able to discuss with you, is how do you make operations that are carried out in the research infrastructure auditable? So it's more than just monitoring what's happening, it's really to create this link between what was the intended policy purpose or the intended purpose of usage, and later on an auditing aspect to be able to verify that all operations that occur on the data have complied with whatever was requested. We have a number of publications already on this topic in the recent year, audit on secure network overlays for multi-domain application, but the idea still comes that you need to have some kind of auditing layer that, as requests come in, is able to check signature of operation. Now, again, I don't have time to go into detail, but if you imagine that many of these applications run containerized in microservices, you need to be able to record whatever kind of information has been exchanged between containers across domains. So I'm interested also to hear if any of you is thinking also of auditable services in research infrastructures. Now, this is also some of the challenges that I think in research infrastructure will come. So there is an auditing perspective, which you could say is a post-mortem or a posteriori verification that you do, but there are also verification that you might want to do beforehand. So before admitting any kind of application in the research infrastructure, particularly when it's carrying around sensitive data, you want to be able to profile the incoming application and to be able to know whether they are abiding with what were the agreements between the parties in sharing the data. So also this is recent work we've made, and again, interesting to know if any of you is also thinking about profiling application, and later on also to be able to, at runtime in the research infrastructure, to determine if the application is actually complying with what was agreed on. So profiling, you could say, could be done a priori, and then there is the runtime aspect, and then there is the auditing aspect, which is the a posteriori aspect. Now, I moved to the last slides. Unfortunately, I didn't time my own presentation, so actually I think I'm going fairly fast to the slides. I wanted then to show you a little bit the vision of where we are going to. So I told you we as a group, we develop, and we have been thinking for now quite a few years about secure digital marketplaces. So indeed, these environments where you can exchange data according to specific policy, verify and audit. And we are now looking forward where we want to go in our research from all our University of Amsterdam research cluster. And we have this idea that we want to actually promote more strongly something which we call the responsible internet. Now, for some of you maybe in the audience, the term responsible internet resonates with a very commonly known term, the responsible AI. And in responsible AI, you have a number of categories of parameters upon which you want to measure and validate your AI applications. And often, depends a little bit which literature you read or which researchers you are following, but it comes down to actually be able to say that something is responsible if it's transparent, accountable, and controllable. So this aspect of responsible AI could also be moved in research infrastructure or in the future internet to create higher degrees of trust and sovereignty. So this is a recent article. So we worked on with other colleagues also in the Netherlands and abroad. And maybe again, for some of you that want to follow up with me on the research we are doing, this could be a good starting point in thinking, in seeing what are we thinking. So trust and sovereignty are element of responsible internet. And the way you can accomplish this is indeed by using specific technologies that are now emerging that allow you to actually achieve the transparency and accountability and controllability you're looking for. This is a bit more of a technical slide. Again, I don't have a lot of time to go into detail, but let me just guide you through some aspects of these intended future platforms. So what you can see here is also, I come back to two concepts I've discussed before. There is, we believe in research infrastructure, in a future internet, responsible internet, in a secure digital marketplace, an a priori phase and a posteriori phase. So the a posteriori phase in networking term would be path verification, for example, to determine that certain data has been moved across certain domains, which were the one that were actually required by the original request. The a priori is trying effectively in the context of the future internet, trying to match the request into whatever paths are available and compose the path through the various domains. And the technologies we can actually leverage to do this are, for example, programmable data planes. We are extensively researching on the P4, but also more generically, SDN, path computation engine, or more recently segment routing, which is also effectively an established technologies to be able to steer traffic and control traffic through the network. And again, I think if there is a message from my presentation to you today is that when we use research infrastructures like the one we are talking about in these 2 days, we will always have to ask yourself, how do I create this loop between what was requested a priori by the user, what were the level of trust that the user wanted, what were the policies that the user required, how do you actually translate into services which are actually exploiting the technologies that are underneath available, and how do you verify at the end. Now here I leave also 2 pointers again for possible discussion for those of you that will follow up with me on recent articles that we had, and maybe I want to just leave, maybe just point your attention to the last article, which is a more recent one, which is about using P4 and RDMA to collect telemetry data. This is also an aspect I would like to hear more from you in the audience, how effectively telemetry, real-time telemetry can then be combined, can be actually acquired in this kind of virtual NVF-based infrastructure, and how actually, or P4 infrastructure, now actually this telemetry data then couples back into the path verification or verification a posteriori auditing layer. This is my last slide, and I'm actually looking at the time, and I think I'm probably more or less with what was allotted to me, I hope. These are all kind of links to projects that I mentioned very briefly, the logistic project, the personalized messaging process, also links to our own research group information, and to some other initiative in which we participate. So I know I talked very fast. I was trying to be able to cover all the material that I had, and I do really hope that I will get questions at the end, or maybe stimulate for more interaction with you in the audience.
Thanks a lot, Paula. Thanks. Very, very interesting. You already got a question. We will cover that in the Q&A session.
Very good.
I'm sure there will be more coming in. So let's switch to our third speaker, Professor Jörg Ott from Technical University of Munich. Jörg holds the chair of Connected Mobility in the Department of Informatics at TUM. He works on mobile networked systems with a focus on network architecture and protocol design for robust, reliable, and real-time systems. Besides building systems, his experimental work includes measurements for data collection and building and running testbeds to inform design choices and validate those systems. So, Jörg, thanks a lot for being with us. The stage is yours. You have 15 minutes sharp. I will be tough, as you know.
As always. I'm just clicking the share button and hope that this will work in a second. First checking, can you hear me?
Yes.
Okay, now.
And now we see the slides.
Now we see the slides. That's great. Okay, so thank you very much, Andrea. I want to share a few notes on scaling and sharing, and based upon our experience that we gathered while building all kinds of test beds to collect data, while Paula just nicely talked about what to do with the data once you have collected them. So this is actually a very nice complement here. So for a little bit of context, we currently work in the area of edge and in-network computing, where we are particularly focusing on obviously mobile users, but also mobile and fixed sensor devices, actuators, and Internet of Things elements, trying to provide mobile services, mobility services, and so forth, but also building those respective service provisioning infrastructure at different in different areas, at different degrees of localities. Well, and we do protocols on systems, so this is the background while we are trying to understand what we are, or what motivates our design decisions. So the edge is a bit of a fuzzy term, so I have drawn an edge at the bottom. So we may have somewhere distant cloud data centers, we have an internet core next to it, then we may have some access networks, and then some wireless networks that get smaller and smaller all the way to home access networks, and then we may have little devices and the users. And so when we think about trying to build a testbed, we can obviously look variously deep into the network, and that then has impact on the scale and complexity of the infrastructure we want to build up. Since I mentioned protocols and services, we can also look at the stack we want to look at from the very bottom of lower layers. Ari talked about this morning, and but also all the way up to applications. So we are probably somewhere sandwiched in the middle. And we may look at geographic surroundings. So I call this breadth here, for lack of a better term, that we might not just look at single providers, but also multiples who run their respective edge infrastructure next to each other. Now, what does that mean for test beds? Well, obviously, in an ideal case, we'd like to capture the entire breadth, all the way from the user to whatever the infrastructure is. And I apologize for this being a server or service provider centric view. We of course also do have a decentralized equivalent of that, but that's harder to draw, so I stick with this one. Our past efforts have mostly looked more on the smaller scales, trying to look at mobile users and building test beds for looking at their interactions, extending that a bit further maybe to base station environments, and now more recently looking at edge and access networks and incorporating those. But as I will show on the next slide as one of the examples, we can also zoom in very deeply on individual users. And in this case, a user isn't a human user, but it may be a vehicle that we can look at closer for test beds. So we have been trying to understand how different things work, and we are not layer one persons, so we do care about networking aspects. But we know that whenever things are close to each other, simulations and emulations quickly stop functioning. So we have been building different types of Wi-Fi networks that fit into a relatively confined space. First of all, starting out with a pure wireless infrastructure that we still built while I was at Aalto University, then extended that now in Munich to a larger one that doesn't require wireless interaction anymore, and thereby can speed up experiments because we have a separate infrastructure for controlling experiments from running them. So that's one style of test beds that is individually usable for yourself. Another one of these that we have looked at is a little microcontroller environment. We are very much interested in lightweight virtualization and actually making the world around us programmable, and thereby you obviously want to start with the smallest things. You would obviously work your way upwards from ESP32s or maybe even Arduino devices to larger scales. So we built an ESP32 node test bed. This is one of the early assembly stages that you can see. Again, self-contained. In this case, only wireless is available for management. To get to some degree of scale, because it's hard to look at hundreds or 1,000 nodes, we also built an emulation cluster that actually interconnects a bunch of very powerful servers with almost a terabyte of RAM each, to run 1,000 to 10,000 small-scale VMs in parallel and have connectivity between them controlled via Linux tooling. Originally, we had hoped that we could go with SDN or P4 as infrastructure, but they didn't provide all the necessary controls for us, so we had to come up with our own distributed solution here. That allows us to move people around in an area and see how their mobile devices interact with infrastructure and with each other, and how applications could actually operate at scale. And then I also wanted to zoom into one thing. The latest addition to our test beds is actually exploring in-vehicle networks, where we are building essentially a software-defined topology at the moment, made out of 12 machines interconnected in the topology that you can see below. I didn't find a nice picture of this. It's currently a bunch of PCs with Intel TSN cards mounted on a cart, so it actually feels a bit like a vehicle. And that is freely configurable, where we're currently developing an Ansible-based environment to configure and test the whole thing automatically, so that we can run entire series of measurements and tests without human intervention. So these four corners here show four things that are not connected. So they are individual efforts, and so this is one of the two things that they share, one being not connected. The other one that all of these four share is when we start talking about scaling, be it experiment or something else, is the requirement to invest a lot into automation. So we have been putting lots of engineering effort into this, and our industry partners, for example, for the vehicle, are asking us, when can we actually get the first scientific publications? But well, we are spending currently about the first year just building up infrastructure, understanding how the individual constituents function, establishing baselines for measurement so that we can afterwards actually work reasonably well and have also some degree of trust into the scientific results we are going to create. So that's the foundation we need for any kind of scaling. Trying to scale up in numbers and topology, and interesting what I would hope that slices will bring about, but we are also currently discussing this in the context of the Piccolo project, is interconnecting different sites in order to build a distributed test bed and interconnect different types of machinery that different people have around. That, of course, brings up the always interesting question, how to maintain controlled experiments when suddenly the links between the sites aren't fully under your control anymore. We may not be always able to build up a separate, dedicated, sliced network infrastructure. Another nasty thing that comes about is things like physics. So if I have my next node in, let's say, in the city of Bremen, I'm in Munich. This is some 700 to 800 kilometers. I'm not going to get sub-millisecond latencies even if I wanted to. Physically, just not possible. So we have a number of interesting issues to deal with. Another dimension that comes in pretty annoyingly when we talk about scaling is diversity, and comes in two flavors. The first one is device and platform heterogeneity. So we have been discussing in the context of our in-network compute system at least half a dozen different in-network compute and virtualization platforms, from JVMs, other interpreters like Lua, to Erlang as an execution environment. We are working with different flavors of unikernels. Then you get containers, you get full-blown VMs. So you get quite a bit of a zoo of technology, and trying to make things comparable. What do you compare? How do you compare? Seems to be an interesting challenge. I'm not sure whether we actually do have best practices that would guide us and future researchers to how to operate this, how to make that, or how to approach this in a structured fashion. Another dimension of diversity comes naturally when we talk about the edge, right? We have many users. I mentioned our experiments for a large scale of mobile users. Mobile users are mobile. They have a behavior. We may have sometimes few, we have sometimes more. And if we have sensors, we also get lots of different that we try to integrate. We will also have not just a gazillion different mobile phones to choose from, but also a gazillion different sensors to choose from, and their interactions. And of course, all these things do talk different protocols. You can pick your favorite IoT alliance, and they will have their flavor, their preferred way of having your devices talk to servers or other infrastructure. You have IETF standards, you have lots of research efforts. And in the vehicle environment, we're obviously also looking at IEEE TSN specifications and their standards, but then we want to compare this architecture to others. So how would, what would be better? The IEEE way, or how much can we achieve by putting the IETF deterministic networking layer on top? And that could be extended further to asking ourselves, wouldn't we rather run a sub-style network to begin with natively inside that infrastructure? So fairly interesting problems to look at. The second part is that I wanted to talk is about sharing, because when you want to scale, you also, it's probably not useful to build stuff just for yourself, and this is what Slices also is about. And when we try to share something, Crawdad has shown that nicely, that we can share data in a public archive. We also contributed data there. We have also shared artifacts in the context of artifact evaluations for different of our research activities. And we learned that there's quite a bit of activity required, or action required, in order to make things shareable to begin with. So this is, again, does the researcher work on making things understandable for others, or does she want to do more cool research?
Yeah, you have 3 minutes, okay?
My clock says I have 4, but okay, I'm almost done. We have a target. We need to think about whom we are trying to address, whether this is individuals where we are handcrafting the interactions, whether we are trying to reach out to our students, which we are currently building, and then we could also just share openly. Obviously, we can provide access to infrastructure like Orbit, and has been doing this, and so have a few other ad hoc networking environments. Maybe also some 6G things are flying this way. Then we have also blueprints to replicate infrastructure like PlanetNet has been doing, and I suppose that slices might also be working into that way. One of the biggest issues that we see is the moment we start interconnecting and reaching out to build something bigger with others, we get the same issues that all the community networks have, that we need to make sure that there's enough people, that people maintain the eagerness and interest in keeping this stuff up and running. And the moment I start replicating stuff, I need to also share a shared infrastructure. I may do this in time by providing fine-grained slicing, time slot allocations. I may do other virtualization techniques. I may do this in space to grab one share of a bigger infrastructure cake. The question is, do I know what I get when I'm getting some part of that infrastructure? And then this is all about sharing experiments and results. Paula just talked about that nicely, so I'm not going to ponder too much onto this. So if I try to look at the challenges, and this is surely not an exhaustive list, we can have some dimensions turn more towards practical, dimensions more towards scientific. On the very practical things, you need space. Also space when you want to scale up. When you want to do radio things, you need to protect against radio interference, either to protect the world from you or to protect your experiments from the world. One of the most interesting things is operations and maintenance, keeping people around who can do this and maintaining continuity for a long period of time, especially when university funding models or job description models don't allow for highly qualified technicians to stay around. Somewhere in the middle, we have, whenever we want to measure something, we need inputs. We'll need the sheer number of different things I talked about before quickly lead to an explosion of experiments that you can do. Stuff needs to be usable and understandable for others, easy to share. John mentioned repos and so forth yesterday. And then we have a bunch of interesting scientific challenges that include, besides building reference models so that different people would actually create comparable experiments, also the question of what is representative, how can we interpret, and how can we generalize. We can look at energy across all these, both for running it and for the implications. And there's a legal and regulatory dark cloud hovering above all of that needs to be taken into account. So to sum up, yes, we want to go for it. An interesting question that I want to raise is how to do this sharing and scaling across different test beds, interconnecting the different things that we have put together. How to evolve infrastructure and keep it up to date. That's also a funding issue. How to transform a test bed into a living lab where we eat our own dog food and generate the data so that we actually do get meaningful inputs. And then maybe also embracing other disciplines that don't have to be experts in that, so that we could have market auctions for resource management or similar things fed in. Thank you.
Thanks a lot, Jörg. Wonderful talk. Thanks very much. Many questions are popping in already. While we switch to the last speaker, I remind everyone that they can cast questions. So there is a tab in the tool that we will use later on to gather them. So any question you have for the speakers, put them there, and I will collect them at the end of the session. So thanks again, Jörg. Let's move to the last talk of the session. The speaker is Dario Rossi, Dr. Dario Rossi from Huawei, France, where he is the Network AI CTO and Director of the Datacom Lab. And before moving to an industrial life, he was a full professor at Telecom Paris and at the École Polytechnique, and was the holder of the Cisco's chair on new networks in Paris. Dario is a very well-known researcher in our field. He has co-authored more than 10 patents and more than 150 papers in leading conferences and journals. He received 9 Best Paper Awards, a Google Faculty Award, and an IRTF Applied Network Research Prize. So thanks a lot, Dario, for being with us. As soon as you will be brought on stage, the stage will be yours. Okay.
I'm trying to bring him on stage, but his invitation is pending. I don't know if he can hear me.
He says that he keeps crashing. Okay, while we solve Dario's issues, then let's take a few of the questions that have been put already on the question tab. First one is for Paula. If someone can bring back Paula and Jörg on the stage while Dario is setting up things, we can let them answer the questions. The first question for Paula is a question from Benoit. And basically, the question is whether you think that the EU legislation is strong enough for user-centric data management.
Yes, let me answer that. Yeah, let me answer the question. I do believe the answer is in general yes. So in principle, it is strong enough. What I think actually we see in our work is how you translate this legislation into actionable operations on infrastructures. So I think the translation of, for example, GPDR policies into what needs to be happening in a research infrastructure where you move, for example, medical data is where actually we as a computer scientists have an issue. So the answer is yes, but then I think that the big problem is how you translate it. Yeah. And so I think this is where actually all these efforts go to create policies that are actionable and then can be audited and re-verified. And I think this is big challenge for all of us in the coming years, when more and more personal data is used, shared in federated machine learning, federated infrastructure, where the data moves around and needs to be anonymized. You have to do all kind of anonymization mechanism, and you want then to be able to guarantee, according to GPDR, for example, that you have not leaked anywhere in this chain of moving around any information. So I don't think the legislation, I'm not a lawyer, I'm a computer scientist, but I don't think the legislation is the problem for us. It's more how you actually cover it. Maybe I move to the second question. I help you, Andrea. Yeah. I just go myself to this second question. For me, it's from my actually colleague Yuri. He asked about Gaia X. We are certainly aware of Gaia X. He actually mentions in the context of Amdex, which is our smart cities and a city initiative for secure digital marketplaces. I think we have been looking at that, but also in the context of our other networking initiatives. So it was in one of the links you can go and look at. 2 stick initiatives also are for us interesting. So the answer is yes, we are looking into it. And more you can actually, Yuri, maybe also comment. Okay. Thanks for the question.
Yeah, thanks a lot, Paula. I have a few more, but let's move to you for the time being. I think you can see the questions.
I can actually respond straight to Adrian first. Yeah, thanks. So the essentially we pick we originally wanted to build a software-defined networking controller, and so essentially we have 1,000 VMs. They all have virtual interfaces, and we bring those that would be otherwise in radio range into local broadcast domains. The original idea was to do this with an SDN controller. But in the end, scale and performance didn't quite work, and not all the features that we were needed, such as controlling packet loss and maybe also limiting rates, were implemented in the infrastructure that we had available. Happy to take pointers if anybody knows such. This configuration is controlled by our our simulator one. That runs when it runs in real time, where it essentially generates link up and link down events, and they get fed via real-time connection into that system. And then it creates links dynamically. And instead of using an artificial simulation, you could also run a trace through that and get the same effect. Then I see another question. The 4 test beds, and they do currently they share common insights. They don't share common control plane, but because they evolved at different stages. And one hope is to actually build a common infrastructure for those. This goes to Serge.
May I actually interject here? I have a
Yes.
very big curiosity for the work you presented. I think I didn't hear the term, but maybe I missed it. What about sustainability of all these scaling efforts? What about the even energy efficiency? How do you combine that? Because I didn't hear you mention it, but I think it's also a dimension. I didn't cover it in my talk, which is coming into this research infrastructure.
I mentioned this very briefly on the last slide, but I was talking too much before. So the short answer is it would be nice to actually have a very good understanding of what the energy implications of all these things are. There was a pretty interesting talk last week at Hot Mobile that looked at the energy implications if you move stuff, if you scale things and put things to the cloud with technology innovations at different points in time. That was using system analytics. I think so. I have seen a number of papers that looked at scaling questions from the perspective of trying to compute whether it's more energy efficient to offload something or do it on the mobile device. Quite often you account for only the mobile device, but not necessarily the holistic view. And I think in that latter into that latter direction, to look at the total cost of performance, that's going to be a more interesting question to answer. I hope that touches. At the same time, you also need to take into account how much energy you burn to do all your experiments. But that's a different one.
Okay. Thanks a lot for taking the first, let's say, half of the questions. Now Dario is with us.
Yes.
Welcome, Dario. So now we go back to your presentation, and then we will have a final slot for other Q&A. So Dario, you have 15 minutes. Thanks a lot.
Yeah, I hope you can hear me.
Yes, we do.
There are no. Okay, cool. So now I'm going to try to share the screen. And if not, I hope that you can cast the presentation that I don't know. Okay, if you're seeing the screen with a very nice effect, right? Infinite effect.
No, it's fine.
So
it's fine.
If you go in pointer mode, it's fine. Yeah, that's perfect. Thanks. Go on.
Okay. Sorry for the usual problems with the new platform. So here, what I want to talk is about the point of view of a user that want to use a testbed-like slices. So from two different perspectives, which are going to be the network perspective in using AI, so how the network can help AI, and how AI can help the network. So these two symmetric viewpoints. So before joining there, let me say that I've heard a lot of things that resonate a lot, and I feel I have a slightly different viewpoint, but that's nice because it's complementary. So before going into these two viewpoints, I need to introduce you the context of AI research in datacom, so in the network branch of Huawei, where we're using artificial intelligence and machine learning to basically speed up a number of things that include humans. And when you include a human in the loop, you're slow, you make mistake. And so you do want to get rid of that through AI and machine learning, as you all know, to basically bring through a new autonomous driving network, a new dawn of the network where the human can focus on the most important task and automate the tedious one. So in Huawei, we do so by taking into account that the many industry segments that undergo through digitalization, transportation, government, I'm not going to list them all, they have an infinite set of requirements that are all different, that brings a lot of heterogeneity. And we're dealing with that through three different scenarios. So campus network, data center, and wide area network, that's with the very important aspect of security, provide a single technological solution to satisfy all the customer requirements. So the solution is built on top of 5G, the fixed 5G, which is intensively based on optics, and Wi-Fi 6 for campuses and enterprises. And on top of that, you have the intelligent IP, which you can think as the new thin waste, where if the traditional IP was used to bring basic connectivity services in a full mesh global scale, the intelligent IP is going to bring advanced connectivity services. And why can it do so? Because there's now a blending between computing and connectivity, so that the new thin waste clearly is using the cloud, the fog, and the edge in order to have these enhanced capabilities. So in this very general, I mean, that's not anything new that I told you so far. So in Huawei, we have a 3-layer solution to address this problem. So you can see the 3 layers here. You have the cloud, which is the central part here, the network cloud engine, and that's communicating with the devices on the one hand, and on a more global scale to, if you want, other cloud platforms. So let me go over this. So you have here something which is the controller analyzer, which takes data, streaming data from devices, and of course you have multiple vendors, not only Huawei. And here you're using the usual type of protocols to configure and to get telemetry. So that's a bidirectional flow that allows you to control and analyze what happens in a network at the very fine-grained stage. Of course, the models that are running here, they are not trained in the network cloud engine. They are more they're trained in the offline cloud, where we have huge monster, for instance, for doing training. So that are shared across many of these iMaster and CE instances. And over here, you also need to have an outbound API to communicate. And in this case, you may be willing to communicate with other cloud platforms, which are not Huawei, other third-party application, for instance, to go from what is a specification of an intent to a configuration of the network and a running of the network. And of course, a network is made up of multiple individual devices. So where here you have a visibility which is at network-wide level, here you might still be willing to do something from each device independently, because then you can have a much finer grained, much more real-time decision making. And I don't know how much you're familiar with that, but there are a number of technological advances that makes it so that right now you can do AI not only with general processing, with CPU, with GPUs, but also with specialized processor like tensor processing unit that comes in many flavors. Some of them are really monsters. They consume hundreds of watts, so they're good in putting it to nodes that then are going to make a cluster of very large, powerful engines. But you also have very tiny devices that are consuming only about few watts, and they can be deployed also in the devices. So if you look into this network stack with respect to an AI researcher, then you have a number of problems. So here, what I wanted to do today was to pick some specific examples, very few one, given the 15 minutes, and try to project those examples into the slices architecture, the slices federation testbed, and how can be mutually useful for us, for instance. So I'm going to split basically this architecture in 2 parts. So one is the network for AI viewpoint, where, for instance, if you need to have very large training, you're going to be subject to something which is the data center network, the data center capability. And so here, engineering the network to help AI is going to be very useful. And that's, of course, something that goes much deeper. But when you go further close to the edge and further close to the real-time loop, then there's something that is only not only how do you do the architecture split, but also how you can leverage AI for the network. And here is where test beds are particularly useful to make AI problem more challenging and so more real. So let me go over so let me go over the network for AI viewpoint. I just put 4 examples in these building boxes here. And those examples are model training. How do you use the telemetry? What they mean by real time, and what do we mean by control? And I was trying also to say what are the 2 key getaway aspects that you can get from what a community and a project like Slices can bring. So if you take, for instance, model training, Federated learning has already been mentioned in many talks, and typically what we were doing is that in real use cases we have real problems for different data sets where there's a portability issue, and so you need to train jointly. And training jointly, of course, is not good if you have two customers that don't want to share the data, so you need to share the models. And the sharing of the models is done through the NIA distributing cloud. And already here, what we're doing at this stage is that we're focusing, if you want, on the algorithmics. And for instance, comparing with Google Federated Averaging. And what you see is that if you start using real data already, the algorithms that exist right now have problems, because in case where, for instance, the data is non-IAD, so heterogeneity that has already been mentioned in many of the talks, then you have a problem of convergence. And then you need to change your algorithms to make it work. Now, already in this stage, you see that heterogeneity brings a problem, but here we were testing the solution in a local test, but we have basically infinite capacity, extremely low delay. And definitely, if you start scaling this up, you will have much more problem, because when the bandwidth is not infinite, when the devices are not fully operating all the time, when you start having this kind of practical system level problems, will bring new challenging insights that are also going to modify the algorithms. So, which is what I think indeed interesting, because if you have a large scale heterogeneous research infrastructure, then it's going to definitely, on the one hand, lower the access barrier to do this kind of experimental study. Not everybody is fortunate, like in Huawei, to have access to a lot of equipment, test beds, data sets. So that is definitely something that is simplifying things. And in the other case, given the large scale, I mean, the talk that just finished before me was speaking about it, then you're also going to have a lot of more realistic challenges. Of course, there are a pain if you need to maintain it, but they are also going to bring new insights into what is really important to make this algorithm practically working. Second point, for instance, is the model-driven telemetry. Yesterday, we were hearing that indeed it's a lot of the time you spend into basically cleaning the data. And if you have multiple vendors, if you have multi-heterogeneity, then you have even more complexity. And actually, it's good to have dirty data, because the first way of machine learning and AI research in the previous decade was basically indeed going through some very simple setting in which, after I have intensively clean data sets, I can do something that works. But that's not something that will work forever. So actually having this dirty data heterogeneity is a good thing. Other things that we discussed that I heard a lot and indeed resonate is, where do you allocate the AI resources? So there may be a lot of trade-offs from privacy, from legal, from cost perspective. Do I need to put in the edge versus the fog or versus the cloud? And what is the impact that it has on the type of control you can achieve? And of course, when you speak about control, it's of course everybody's talking about the magnificent thing that you can do with deep reinforcement learning, for instance. And we're also doing that, and we face problems such as the fact that when you train in order to train your engine, you need to train it over really a large number of simulation, because you cannot learn just from the network, because it is quite evident that right now the deep reinforcement learning takes ages to train. All the games that have been trained, it's several hundred years worth of testing. So definitely when you work on simulation, and then for instance we deploy on the real network with that we have in-house, which are fairly large scale, you would want to have something in the middle, which is a controllable, reproducible environment, where still you get the delay and the noise that is typical of the real environment. And that's good, because it's going to make your algorithm a step in between the magic world of simulation, where everything works, and the very complex work of real network, where you have no control at all about the input condition, for instance. So when you do two tests in a row, you're not sure if it's the algorithm that changed or it's the condition that changed. So you cannot really compare things in an apple-to-apple manner. So here again, having the benefit of that is that right now the community is also pushing for reproducibility to publish, which was also mentioned by John. And so that can be something where you start having a large user community, you start having also a critical mass to push this kind of reproducibility standard, and hopefully making a research workflow that is also more useful globally in a global scale. So that's what I wanted to say for the network for AI viewpoint. So let me take the complementary viewpoints on looking at what is AI can do for the network and how can you benefit from doing that on a testbed. So here I took...
You have 3 minutes.
How many?
3 minutes. Thank you.
Awesome. Yes, thanks. So here again, I'm taking the complementary viewpoints. So I'm taking, for instance, different aspects. So here, model-driven operation and management means that you need to do something typical like anomaly detection. And in the case you're Huawei, well, then you have a lot of test beds, and you have a lot of data, and that also is labeled data, but you cannot share it. In the academic community, you're still stuck into having KDD99 tests. We don't have something equivalent of, for instance, an ImageNet. And here, the large user community means that, for instance, you have a critical mass for crowdsourcing. If you need really to have that people would want to work together, competing in a fair manner in an academic way. Heterogeneity is again useful because when you think about the lifetime of a model, the model will age, the data will drift. And so it's really important to study an imperative what will happen to the model in deployment. So you will need to have, for instance, to know whether the model will work or not. Similar, if the model doesn't work, then we will need to do incremental training, and incremental or continuous, depending on how many passes you do on the data, will bring new algorithmic challenges, particularly if you want to do that in realistic settings. And finally, also about the inference. So where it's not just that you need to do AI, you need to do AI in a world where the Moore law is vanishing and where everything has an energy cost. So you want to do something which is a parsimonious AI and not just trashing a lot of computational power. So here, for instance, having the possibility to have CPU, GPU, and TPU deployed will allow you to do some of the comparison that typically are not done in the class of the image field, where the type of workload are completely different from the one in the network. So I think that I can stop here and join the second half of the question session. So thanks already for listening. I didn't put any specific reference. The public ones that are publicly accessible are here in this on this website. Now I'm stopping here and stopping the sharing and resuming the panel discussion.
Okay, thanks a lot, Dario. Thanks. Very interesting to see what you guys are doing in Huawei. It resonates a lot with what we discussed in the previous talks as well, which is very nice. So a couple of questions for you already. First one is from Frederick. It's actually similar to something that I wanted to ask you. So do you put also the individual devices into the picture of federated learning the way you do it? Meaning you are an infrastructure provider, but you are also an terminal provider. So in principle, you could see also terminals, what we used to call terminals, so user devices as part of your infrastructure in order to do this distribution of AI tasks. Is it something that you see coming in the future or not?
So if you wanted the definition of federated learning, like Google Way started exactly this way, and indeed we're pretty large. So we also have the customer business group, the CBG, that is making devices. Actually, I started the edge, so I consider the device out of the loop, also due to the number of specific aspects like the paramount importance of security and privacy and sensitivity in this case. So there are people that are working, for instance, on how to encrypt the weights that you have least possible amount of leak from the models. We take a slightly different approach. So for me, a customer, for instance, is a big ISP. So definitely devices in the federated learning way could be, I mean, they are part of scientifically the question. That brings a totally different operational point in terms of scale from the one that I have in mind. So yes, it's possible. We're not considering from things that are close to me.
Okay. Okay, thank you. Next one from Yuri. Okay, it seems that you are using a lot of cloud-centric and cloud-native approaches in your view. So can you elaborate more about that? And it is expected that the network provider will create their own clouds or use public clouds.
Mm-hmm. So I don't want to go and make advertisement for own products, but the iMaster&C, for instance, is something that is running on a cloud. Actually, there's one cloud in Europe. It's in Hungary, and is used by the European operators. And it's a cloud provider that is basically an infrastructure from Huawei, but it's not directly operated by Huawei, in which the operators are, so they don't need to deploy their own infrastructure if they are small scale. Of course, if an operator is large scale and you want to deploy its own cloud, you can. If you want to go on another public cloud, you can. And indeed, that was the part of, in one slide, you have the iMaster NAIE, Network AI Engine. That's the private cloud of Huawei, where you can have individual slices for individual operators. If you want to go with a public cloud, you can. And if you want to deploy your own, you can. That's depending on the type of scale you have. The advantage it brings is that indeed you need to have some central point of where you have a network-wide visibility. And so that point where you want to put it in the architecture, before the AI thing, it could have been a PCE element, right? So you still need to have some central resource allocation, central policy. So still, this is something that is going to be useful. And if you are quite adequately scaled, then you can deploy your own. Otherwise, there are multiple ways you can do that. So there's a tension between what you can do distributed fashion and what you can do in a centralized one, which indeed is very interesting from a scientific viewpoint. Of course, in terms of time today, I speak a lot, speak fast, but I didn't have the time to further elaborate on that.
Okay. Thank you, Dario. There was one question to Jörg, actually, from Chadi. And the question is again on mobile users. So how do you plan to support basically experimentation with mobile users? I would add one more thing to that. How do you think you can do it when you are not doing your own experiments, but you are providing your facility for external experimentations, if that is part of the plan?
The latter part isn't fully part of the plan yet. The mobile experimentation is integrating mobile users is a really difficult thing to do. For one, we are trying out all kinds of tools to assess mobility patterns to some extent, but that doesn't really help. Then this comes a bit down to trying to provide a bit more like a living lab environment. We have been trying to wondering what we can, with what we else besides little sensors for temperature, humidity, CO2, and whatever we can equip our corridor, and then automatically switch to actually using our own infrastructure by the people at least whom we have around. For a larger scale, I'm not yet clear how one would do this. I have seen papers where people actually scripted mobility patterns and gave people clear instructions on what they should be doing. These user studies are, of course, super expensive in terms of time and effort, hardly reproducible, and so. I think this is a very interesting open direction that Chadi pointed out here.
Okay. Thanks a lot, Jörg. I have one question for Paola. So basically, from your standpoint, from the standpoint of what you presented, what is needed in terms of networking? I mean, we have been seeing from Ari, for example, that 6G is, as any new cellular generation, is going to provide more bandwidth, faster networks, and so forth. From your perspective, from the perspective of data management and the use of data, is that enough, or do you think we will need some completely different type of networks in order to support that?
What I see the big challenge in the work we do is the multi-domain aspect. So when services will need to move multi-domain, and when you will have, particularly the work I personally do, because I describe the work of the whole cluster, has to do with instantiation, for example, of virtual services, NVFs. And I still think the coordination, the path computation across services, across elements in domains as being one of the big challenges. So not per se the bandwidth, but really coordination aspects across domain boundaries. And again, in federated learning or in all this kind of environment where you move across administrative domains, you will have these things to solve. So that's to me seems the coordination across domain. So it's not just distributed computing or distributed networking, it's really multi-domain aspects, which I think SDN in itself didn't really solve, right? Because SDN still worked very well within one competence domain. Okay. Yeah. Thanks. One last question, then we have a short break for Dario again. The question from Yuri: is network for AI an alternative to current AI machine learning platforms like Hadoop and Spark, in your view?
Well, yes, in the sense that Hadoop and Spark are very nice tool, but they are not necessarily designed for a network workflow. So I'm just gonna make one very simple. So Hadoop is batch, so okay, you can do whatever kind of batch analysis you want, but it's something that is from the past, I would say. Spark or Flink or whatever you want are very nice tooling for doing a part of the analytics, but they are not necessarily working at scale. When you're working at scale, tools are completely different, so already scaling those things up are different. But imagine that most of these devices, for instance, or even the GPU acceleration, etc., work in batches, and most of the things that you want to do in network is per flow or per packet, where you basically don't have a batch. You don't need to wait. And in order to bring the analytics to a very fine-grained, granular way and in a manner which is cost-effective, if those devices are being optimized for working in batch, for large images or for large chunk of data, well, then we have a problem. So definitely, you cannot just go and plug these devices. They are going to be useful for part of the task. We are using Kafka Streams, Kibana for telemetry. I would not use necessarily that for control. So definitely for checking what is the status of the network respective to the action that I've done, okay, that's wonderful. For doing fine-grained telemetry and control, you need to be more precise, and then you have very niche problems that need to have very tailored solutions. So yes, there's a lot of space for more things than the two we just briefly mentioned.
Okay. Thanks a lot. Thanks again to Paola, to Jorg, to Dario, and to all people attending the session. It was very, very inspiring for us. We have a short break now. We resume in 5 minutes from now, and we will hand over to the next session. Thanks a lot, guys.
Thank you.
Hello, Thomas is speaking.
Hi, I just invite you on stage. I'm trying to invite also the rest. Just to make a test.
I make a test with my slides, so just presenting my slides.
Yeah. Let me find.
I know it, how it's going. Just very quick.
And the last one is.
Can you see my slides now?
Yeah, excellent.
Okay, then we have done it. Okay, so we are solved. Oh, good.
Okay, and I will invite also Sebastian. Where is Sebastian?
Hello.
Hello.
I seem to be muted until it's my turn, right?
Okay, Sebastian also is coming.
Everybody, do you hear me?
Yeah.
Wonderful.
Okay.
I hear you and see you. Everything is fine. Hello.
It's a pleasure to see you, Thomas, Vanya, Diego.
First, we will have on stage you and Thomas, and we will invite speaker by speaker on a row as is on the program. Thomas, we don't have your presentation, but you checked that it works, so you are fine.
It's working. I can. I will. I've checked it before. As my presentation was able to share.
Try to share your screen and then go to application window and share your application.
Done. Here. Boop, boop, boop. Should be
okay,
visible.
well, perfect. And go to presenters mode so to have the full screen.
Yeah, for sure. That I will do.
Okay, so I'll leave on stage Thomas and Sebastian, and I'll take out for the moment Diego and Vanya, and I will invite you when your time will come. Okay. If you want to check your browser, you can do it now.
Well, if you don't mind, I will check as well my share.
Yeah, try to do it.
Share screen.
And we have Sebastian around 10 minutes, let's say teaser speech, so to say, that we can discuss a little bit, or 10 to 15 minutes. Or.
Oh, I will just make a very brief introduction.
Okay. So I hope you see everything, right?
Excellent, excellent.
Okay. So excellent. Stop.
Vanya, would you like also to make a test of your presentation? You cannot. You are muted. You are muted. We cannot hear you.
So, Thomas, a question. Are you still Chief Expert Software Corporate Technology at Siemens? So,
Vanya, would you like to your browser and your presentation? Go to sharing your screen.
Thomas?
Yes, I hear you.
Right. Just how do you want me to introduce you? What is your current title at Siemens? Because you were
Chief Expert. Chief Expert is something comparable like a fellow in other companies, because it's a little bit strange title which we have in Siemens sometimes. It was named fellow in other companies. I explain it always.
The presentation works okay, but you have a problem with your mic. We cannot listen to you. You are not muted. You have to allow the browser to use your mic.
Thomas, so BDV has changed its name officially, so
leave it as a moment as BDVA. We are a Big Data Valley Association, and I will give. I have later in one slide, I think, the new name, and I will address this.
Okay, very good. So I can introduce you still as BDVA president.
Yeah, for sure. It's also the reality today or tomorrow, hopefully.
I'll send you an email. I'll take you off the stage, Diego and Vanya, and we'll start with the session. Okay.
So the idea is to have about 15 minutes each for the presentation. I will be very brief for the introduction, and then to have some time for question and answer at the end. So I prefer to keep the time for the end of the sessions to interact and listen on your views and perspectives.
And I will touch briefly some outside-in view, what is the market requests, focus on AI and data. So and then I will dig in 3 examples from Siemens. Will also touch 5G, but because then you can speak about, and then I will make the view on the European perspective, briefly touch what is doing in Gaia X, what we are doing, and in BDVA regarding the partnership, how this fit together. So this is also, and then of course again going back to my manufacturing responsible and saying, okay, on what we need from a manufacturing perspective. That's all. Perfect.
Very good. Excellent. I think it's a very good approach.
And you can get later the slides. It's a little bit big because there's one animation inside I have seen 70. Don't ask me. Megabytes big. But the PDF version is easy to send.
Very good. Perfect. So I will
try to keep the time. Trying to keep the time.
Yeah, sure. Stavroula, is it solved with, was it Diego who had a problem with the audio?
No, with Vanya, but we will solve it, no problem. Okay. You can start.
Okay. So good morning, everybody. It's a pleasure to chair this session with 3 talented and expert speakers from 3 different perspectives and representing 3 European industrial leaders. So it will be interesting to see what is the connection between the research infrastructure, the research strategy, the needs from the research infrastructure perspectives, in order to address the requirement, the strategy, the needs of the industry in Europe, in order to avoid having a research infrastructure which is disconnected from the economic reality. So it's my pleasure today to welcome, first of all, Thomas Hahn, who is a fellow of Siemens, who has been a lead technology expert for Siemens for many, many years, but who is also the president of Big Data Value Association. We'll tell you more about it, and the transformation, the evolution of BDV. I think it could be interesting for all of you. He's also active in other fora, but I will let him introduce as a quite strong commitment in the research community and building bridges between the research and the industry. I have also the pleasure to have with us Vanya Conan from Thales Group, who is leading the research lab of Thales in France, and who will give a perspective more related to the cybersecurity perspective and another angle. And then we have also Diego Lopez from Telefonica, who will bring the telecom operator perspectives in terms of perspective, requirement, the visions in terms of future research, future networks, and the needs and requirements for supporting this technological evolution and enabling these different stakeholder researchers and industry to work together to bring new technologies to the markets, to the citizens. So without any more delay, I'm pleased to give the floor to Thomas Hahn, who will start by presenting his perspective on the future opportunities with data and AI. What are the needs, perspective of manufacturing industries? Thomas, you have the floor.
Perfectly. So warm welcome to everybody. Highly appreciated to make this speech. And I hope you see the slides. I think, okay, that's great. It's only the last check. And many thanks, Sebastian, for the introduction and presentation. Yeah, 3 to 4 topics I will address. One is very brief outside-in view, why we are striving this, the data and AI. I think everybody is aware of what are the challenges, what are the opportunities, and what we have to do. Second, I will slightly touch a little bit how we are addressing this inside the company Siemens. Only to give you a feeling, I will also touch, I heard that yesterday was regarding 6G, for example. I will telling something about also communication applications with 5G, what we are doing. And last but not least, I will make the outside view regarding European project in this area, European initiatives, where BDVA, but also Gaia X, for example, where I'm the vice chairperson in the organization, and how this fit together. And last but not least, some thoughts from industry perspective. Yeah, what's happening, you know, this is from IDC, some numbers, and as I said before, it's a little bit more focused on the application regarding data and AI usage to create impact. And this is some kind of numbers which we elaborated or not we used the numbers coming from IDC about the future investment spending total and overall. So meaning across the different domains, when you're looking at the left side or on the right side regarding data, there's an increase of spending over the next years, which is seen covered, let's say, across the different topics, meaning that also when you're speaking about research aspects or some kind of cross vertical topics to be addressed. The same picture is, you know this, and maybe you know this about, because we have AI data, and I'm representing also the AI data and robotics partnership, which will be launched soon in Europe. Also, when you're looking at the robotics part, and you see here the planned increase or the forecast from Statista about the amount of thousands of robots in the different regions of the world. And you see here for Europe, and you know the relation where we have to look how to improve this, because, you know, this is always a risk for us that we are not in a position and to be and to have to keep also in different domains our leading position, but in other positions we have to speed up, you know, that we are to make it concrete in robotic stuff, uses a robot behind, especially China and not China, Japan and Korea, sorry for this, but you see also that we have only a slight decrease in comparison to the plans to the other one. So in a nutshell, and this is really an teaser from outside view, we have to do it, because this AI data, robotics, autonomous systems will challenge us, will be a pacemaker in the future for different domains. You see in plant investment. We are at Europe in different domains in the leading position, you know this. We are also exporting and cooperating also with other regions in the world. It's not a contradiction, especially when you're coming from a big company, but nevertheless, we have to address this. This is, let's say, somehow to give a snapshot outside view with some numbers, and you can get also the slides later, and also with some kind of statements from industry. You see here, for example, from Philips, the CTO, or from Siemens, Roland Busch. Okay, the older slide is in the meantime the CEO from Siemens, Peter Mohnen, KUKA. But you see here, or SAP, Jürgen Müller. But you see here also from the academia perspective what are their thoughts with respect to AI data and what we have to do regarding autonomous system, embedded AI, and so on, to be strengths and to enhance our strengths also for the future. This is, let's say, somehow as the outside view. When you briefly allow me to touch what we are doing inside Siemens. You can imagine in the smart manufacturing or industry 4.0 domain, also AI topic, the autonomous topic is needed of connectivity. I will come later to this. Is needed. You see here on the middle, and a robot who was trained to catch, let's say, some kind of strange, in this case, wooden pieces. But you can imagine that is a topic where you have really to look how machine learning, how AI, how data usage, how connectivity to data, how link to data is needed. Yeah, self-adaptable systems catching the different topics. Or on the right side, you see here an assembly, and you see here maybe far on the right, maybe some kind of screen popping through. So meaning is that the operation also learning, you have not a fixed program, so to say, how to assemble this, but you have a flexible way to adapt depending where the pieces are, where to put the pieces, let's say, on the backplane in this case, how the two robots are, in this case, agreeing to each other, which they're doing. Meaning, let's say, the topic regarding AI, regarding learning, regarding uses of data, you get meaning also to get value out of the data. You know, you can also, the maintenance stuff, the improvement of maintenance is also other examples inside is from high relevance from us, from the outside view, but also for us inside the company. And I know that you have yesterday also spoken, when I'm right, about 6G and future communication topics, and you can imagine that this is also from high relevance from us on a shop floor, but also across the different plants. Meaning if you have some kind of mobile connectivity needed, also autonomous machines topic, also on the shop floor, the connectivity is needed, or also when you have this autonomous logistic topic, only to touch let's say 2-3 topics. You know this, I can really make it quick. High relevance, only to give you a feeling where we are looking at and where we are active in, and I will show you later also an overview about our research activities. 5G, you know, I mentioned this. Why is this interesting? You're saying, maybe you can say what is relevant on the shop floor. Yeah, okay, the interesting part is, of course, the enhanced mobile broadband, the red box more on the topic, because then you can really transfer data, video signals, and so on. Let's say on one line, on one connection line, or on the other side. And this is relevant because when you're in a manufacturing environment, you have to have some kind of reliable real-time behavior. And of course, this is a topic where we are inside. And you see here from the profile, this triangle, where we are from an industry profile, seeing, let's say, the 5G needs for us. Of course, when you're going to massive connectivity with a lot, for example, mobile devices, telephones, smartphones, or something else, that is more what the public profile is. In a meaning, in a nutshell, the AI, the data usage, the connectivity uses, also the connectivity usage in areas like 5G, or when you're speaking about future 6G or something else, is from high relevance for us. And therefore, and like promised, and brief overview about what we are doing. You see on the left side, let's say, our research and development spending in billions. Yes, it's written down. So we have around 5 billion, slight increase in the last years. Of course, you see here we have some kind of carve out, Siemens Energy or Siemens Healthineers. Of course, it's always a big company that changes. But nevertheless, you see here an increase. But more important is this green box where we're investing $500 million for topics like analytics, like system and process, energy system, materials, think about additive manufacturing, simulation, connectivity and edge, think about the 5G topic, autonomous robots, only tool touch, think about my examples, but also going down, maybe surprisingly, also not surprisingly, also in the blockchain. So we have a lot of research activities inside on top of our, let's say, classical research and development of our products and solutions. This is somehow it's a view from outside, internal, what we are doing. And now I will briefly touching a little bit the European activities. First of all, is also my credo. We have to have a holistic view when we have to create something value. With methods of AI out of data. Then we have the connectivity. We have to look how the different systems are interlinked to each other, how we deploy this, how we compute and storage, where the cloud, edge, and topics are coming on onto the umbrella. This is on the left side. And as you know, we have some kind of environment conditions, meaning, for example, in our area, quite often functional safety, but also the security stuff, I think is touched later with cybersecurity, but also how we are acting, especially when you're in an AI environment. What is the impact? How to trust? Is the impact really good for the society? In the middle, you see we are doing this not only what we have to do this. We are looking also what is the business impact. This is the other dimension you see on the top. some kind of triangle. It's from St. Gallen, the business model navigator, which also helping you to deduct, and this is the industry voice, what a new value proposition, what are new business models. And last but not least, this is in the nutshell where we have this collaborative aspect topic. By the way, in Aarhus, I used a similar slide, so this storyline is quite stable. Brief touching only 2 topics, because I think there's an opportunity. Like said before, I'm a vice chairperson of Gaia-X. You know, we have the well-established and good ecosystems, but we are looking here from European perspective also, what can we do, how we can make a federated architecture for cloud system. I explained this in a very brief sentence. Always, I know this is very abstract. Up to now, we have looked to the IoT devices, let's say, to the bottom, let's phrase this, and speaking about interconnectivity, description, semantic of the different devices, and trying to make this one. With Gaia-X, we're looking, let's say, to the top, to the cloud systems, and how they can interact, how the data sharing can be done, how, let's say, the federated aspect can be followed. And that's the reason why, you know, this we have in Gaia-X's X, so to say, where we're speaking about the data ecosystem, think about my applications, think about which I've shown before, or in the bottom you have the infrastructure, and as a linkage point, the federated service as a green box. For the AI perspective, because I have to look at my watch, not running out of time, we have filed a topic around how an AI framework can look like, what technology can be done, and what is needed and what investment areas should be done. How does this fit together? And here I tried really, because in Europe we have a lot of activities, it's good, but here for the certain aspects, you see on the left side some kind of technology stack. You see in the bottom the technology readiness level. You see here the IoT topic, 5G for example, 6G. You see the Gaia-X as data infrastructure. You see here the data value in industrial AI, where it's BDVA or DIROS, this is a new name of the association is, and you have the vertical aspects. This is somehow where we have, for my feeling, a good map about this, how we can benefit from emerging other and address this. And on the right side, you see the relevant initiative. Is this the IPSAI project? Is this Alliance for Industrial Data? Is this the European Data Spaces? If you don't ask me from the IoT perspective, the other topics, and by the way, also this conference. So this is in the nutshell. And when you're asking me, and now I'm looking back, here I only give you some snapshot, was from our perspective to close the loop to the domains where I'm inside, what we need in the area, what is needed, what are the reliability, the latency, what I mentioned before, functional safety aspect, and of course the impact what we want to create. This is in a nutshell, hopefully very brief and teaser speech about what is driving us. Thanks a lot.
Thank you very much, Thomas, for this inspiring vision. And I think we will come back during the Q&A on some of the elements you mentioned. I think in particular,
exactly.
Very good timekeeping management. So thank you very much and very inspiring. May I give the floor now to Vanya from Thales to give her vision on cybersecurity. So Vanya, there is a sound. I will switch on.
Okay, can you hear me?
We can.
Very good. I'm just sharing my my slides just now. It will take just a second. There we go. Can you see the slides?
We can.
Okay, very good. Thanks a lot. So I will be giving you an overview of the perspective from a Thales point of view. So I belong in a communications division, but I will give you in this talk a broader overview of the Thales perspective on future digital infrastructures, 5G and beyond, 6G, as we mentioned. Yeah. So let me start a little bit by explaining what Thales is doing and why the digital infrastructures are so becoming increasingly an important topic to be addressed by Thales as a whole. I show here in the five divisions, I would say. So you have ground transportation, space, aerospace, defense and security, and digital identity and security. So five divisions that represent the activity of Thales. Thales is dealing mostly with embedded software and electronic components and subsystems and systems. So dealing with these five markets or topics or domains. And because the commonality has to do with the technology, but as you understand, there's a large variety of domains, but also the roles that Thales is playing in these different domains and markets is not always the same. So Thales can be a technology supplier, and this is true if you think of space, where the first telecom satellite manufacturer. You can think of components with the SIM. The Thales has bought Gemalto, so SIM cards is one of the technology that provides for networks and infrastructure. So that's the first aspect, and it means that we bring in some technology in the different infrastructure, but increasingly so. What is important is to keep the system view, so not just the components that we provide, but also how the different platforms that we bring the electronics or the software to, the intelligence basically. If you think of trains, for example, what we do is we build automatic trains. So for underground today, but increasingly what we see is that we bring autonomy to the different components, and autonomy means that you have to take into account paradoxically maybe, the overall system view, how the different platforms connect to one another, how they connect to the rest of the environment and the rest of the well, how you control, but I also give them autonomy. So that's really an important point of view. That means that whereas telecommunications, networks were seen as either just from the component point of view or from the provider point of view, now they are really part of the entire design of the solutions. Even if it's only a subsystem, it has to take into account this dimension increasingly so. And this means that for the 4G was not a major topic as for the Thales group. 5G is a game changer in that respect, and this trend is going to continue grow increasingly in the future. So that's really where I see the major shift here, and the impact of thinking in terms of digital infrastructure, so in terms of how we integrate the system, and what are also the service that can be built on top of that. A lot of what Thales does has to do with criticalities, security. So this is typically a domain where there are new challenges, but also new opportunities for the digital transformation of Thales as a group. If we look now a little bit more into the technical scope of that we have to deal with, well, the scope is very broad. So I won't go in every single one of them. What is important is that we increasingly have to think in terms of the broad interconnection, end-to-end connectivity aspects. And if you think in terms of how things are structured in the 5G environment, then it means that what we want to produce, what we are delivering, are solutions, subsystems, and systems that address vertical, as you understand, vertical markets. And in that sense, some of the subsystems are some digital infrastructures dedicated to specific vertical cases, train management, for example, drone management is another example that we can think of, and many more indeed of these issues that have most relevance in our case. This is really just the thing I want to insist upon is it's really a major change for Thales engineers, because, and it also means that we need tools to and processes, of course, but tools to validate, to evaluate, to test our solutions with this perspective in mind. One of the other very important changes in the way we design our solutions is that for a long time we've been focused on building components, building solutions, so providing onboard equipment for aircraft, building a video control room, so providing the equipment, the IT, the software for actually the customers to then run the solution, and basically our focus was really on building components, building solutions, and letting customers run things. Now, of course, things are changing very much, because the focus is not, I would say the focus is not anymore on building things. Of course, we still have to build them, but because data monitoring is so important nowadays for customers, they want to build values out of their data. Then it means that we have to look at things in a much more dynamic way, and we also have to look at how at the run aspects of what we are of the solutions that we are developing. So it's both sides. It's also, if we develop a solution which is networked, of course, a network system, then we introduce some monitoring, dynamic monitoring of the solution, of course. But it also means that if it's a subcomponents in part of that, then it has to take into account the whole dynamics of that. It has to take into account the data processing, the data generation and processing that customers want to put in place, either run by them sometimes, or delegated to that's kind of services that Thales can offer. So this is really a major change, and that means that when we want to validate our solutions, then we need to take this aspect into account. In our test environments today, this is not well covered, and I think this is a big need that will grow in the coming years that we have to take into account. Also, some other this is maybe very important, because some of the added value that the solutions that we provide focus on are criticality, are the idealities, some non-functional capacities. That's
yeah. We have 3 minutes left.
Very good. This is my last slide. So what is important is criticality, is adding cybersecurity and resilience to the solutions that we provide. And what is here the game changer, I would say, is that we have to we increasingly include AI type of solutions in the system subsystems, and this means that this increased autonomy of the components has to be taken into account, tested, validated in a way we provide, we ensure good quality of the solution that we provide. So that's really the other challenge I see that should be taken into account when actually making some evaluation of our solutions and testing our solutions. And that will conclude my talk, and I will be happy to take questions at the question session. There you go, Sebastian.
Thank you very much, Vanya. Thank you for keeping the time. May I give the floor now to Diego without any more delay on behalf of Telefonica.
Okay, thank you, Sebastian. I will start sharing my screen. Let me 1 second. And so I hope everything is fine and you're seeing it. Basically, the idea when thinking about what to talk from an industrial perspective here, and taking into account we were talking about large experimental facilities and all the like. I thought that it was a not so bad idea to talk about what we are doing precisely in addressing something or going in a direction that is somehow similar to what other industries are doing, and actually towards other industries are doing, and precisely relying on the network for many of the features that they're using, and it's about the digital twinning. And well, to some extent, it's precisely this discussion goes about this saying about eating your own dog food. The idea is that, well, I'm not going to go into detail what a digital twin is and why it's used, but because it's something that we all are aware of, and digital twins have been mentioned yesterday and this morning as well as a relevant application, and including AI, etc. There is something that has been widely and well, I would say successfully in most cases applied in the industry, and the idea, as I said, is that is to bring it to the networking industry. There is a list of the main elements, and precisely the idea is that while these main elements are general for any kind of digital twin in sense of sensing and acting on the plant, they are mirroring the application of artificial intelligence. because otherwise you cannot build the twin, the mechanisms for communication and representation. There are a couple of things that are extremely relevant in the case of networks, or I mean, in particular, trust is key in the case of networks or other critical infrastructures. You have to establish tight trust link with your digital twin on the one hand, and well, from the network to the twin, and from the twin to the plant in general, because it's about being sure that you're receiving the proper data and that you are receiving the actions from the right origin. In the case of the networks, there is a last element that becomes essential, that in other cases probably you cannot consider that much. I remember the first example I saw of a digital twin was about something that was twinning a big oil tanker. Well, the privacy that you had to preserve in an oil tanker is probably limited to the members of the crew, and even in that case you have not to think about it, because it's more about speed and courses and stages of the different tanks, etc. But when it comes to the network, and we're talking with traffic, personal data, etc., and where Paola was talking precisely about this, about fairness and putting the user at the center, something that is essential is that whatever the exchange, whatever you make in the network twinning, is respecting privacy, and for sure, we're talking about a highly regulated environment and regulatory issues. Curious things with the networks is that whenever we have tried to build an experimental environment that is suitable to reflect the network, is well, we have hit what I like to call Borges' executive paradox. If you look at the right hand side of your screens, what you will see is the whole short story written by Jorge Luis Borges, that I personally believe is one of the highest geniuses in literature. Is the story of an empire that decided to build a map that was so detailed that it ended covering the whole territory. This is why, in particular with networks, because the value we have from Metcalfe's law, the value of a network is proportional to the square of the number of users. So the more complex, the more valuable. But at the same time, if you are not able to mimic this complexity, you are not achieving a real analysis of the impacts of any decision you take on the value of the network. Second is about, I prefer to call them laser effects rather than viral events, as they come and viralizing, etc. Talking about viruses in these days is sort of as a very, very bad joke. So yeah, and is this situation in which many different users, many different connections, not necessarily users, maybe devices, start to work in a coherent way, and what they realize is something that goes well beyond whatever is not coherent, and is and if you think it is just as happens with the laser emitting, and that has defined many of the situations in the recent threats and problems we have been suffering in the networks. And apart from that, there is a set of invariants that we tend to forget, which is about precisely that networks real networks not only have a topology, they have a geometry. I mean, they had to be in a particular place at particular points, because otherwise they are not useful. For conservation, networks are transmitting media. They connect 2 points. They are not consuming data or only providing data. They are moving data around. And for sure, openness. Openness is something that is not necessarily a characteristic of a network per se, but is essential in this world in which we are obliged, all network providers are obliged to cooperate and to interact in an open and fair way with even with our direct competitors. But on the other hand, this is more desirable as ever well, we're talking about, I was talking about what comes with 6G, and let's call it a hyper-connected society. Even for 4G, we're talking about at least one order of magnitude higher intensification. The technologies are heterogeneous and will remain being heterogeneous in spite of whatever we try with virtualization, with cloud-like infrastructures. Heterogeneity is here to stay because the different environments in that hyper-connected society will require different mechanisms, at least, and to start with access, and in many cases as well, at least for the following stage. And well, more and more people is using to think about something that is networking and something that is centralized, which is sort of a contradiction, and it's if you think about it, it's completely against the spirit of the internet itself, but it's happening. I mean, we have more and more centralized services, more and more centralized relationships, more and more centralized interactions, and this is something that we have to, if we want to go to a more distributed, more natural environment, or even try to achieve what Jörg was presenting before when talking about the Piccolo project, is an additional challenge and complexity in how to deal with it. And well, for sure, we have AI. I mean, AI or automatics, whatever. AI, and this is something I probably you have, if you have seen, have watched another talk from my side, is something that I have insisted very much. In general, applying control, closed control loops, in general, is nothing new. It's nothing that is extremely original. Automatics have been around for a long time, more than a century. But well, with AI, you have the possibility to derive further insights and to improve the way in which humans interact with the control mechanisms, as long as the AI is explainable. That's another story. And well, it's true that the more we advance, and I personally believe that when AI, what we are going to achieve is precisely to have very useful autonomous mechanisms, but not necessarily self-conscious or whatever that could eventually happen. But in these days, I prefer to think that we are going to have helpers as useful as a dog or a horse can be, rather than Skynet taking control of the whole world. And again, but when we're talking about the how to apply automatics, how to apply AI, etc., we have to be again aware of the topology and the geometry awareness, this conservation principle of being a medium and not an end, openness, and we have to maintain things. We're talking about a critical infrastructure. We have to be extremely taken extremely seriously integrity and auditability, and guaranteeing isolation in the moment you have more than one use in the network. And well, the famous slicing is precisely about that. What is important is when we are going to apply AI to networking, whatever the nature, and in particular when talking about digital twins, is that networks in general should not be that much. It's not that we are claiming for an invention of new models. We're thinking when we're doing AI, we are trying to mimic the way in which natural intelligence works. Second, as the important thing is that it's about the flows from the controller and the flows to the controller, the feedback signal and the actuating signals, and the architectures. It's true that we can think, instead of having a single one, AI is more about thinking in terms of something like a nervous system. And for sure, we can rely on software networks, on SDN, NFV, etc., as main enablers. So if we focus on the two flows, on these actuation signals and these feedback signals, again, which is important thing, we are working in a couple of projects that are focused on that. One is in 5 Growth, that is about precisely very much focused on experimenting, testing, validating situations, and how to support, to provide the data infrastructure able to support this. And that they address properties for these data flows, about making them usable, making them sufficient, making them safe, and making them steady. So we believe these are the main characteristics that you have to have for a feedback data flow that is useful. On the other hand, it's able to deal with heterogeneity. So as I said, networks are heterogeneous by nature, and the idea is that the data sources are going to be complex, heterogeneous, and in many cases trying to fulfill different purposes. For this, what we're working is in a data fabric that is based on metadata. So you can declare and announce data availability or data consumption in a way in which the data fabric can connect these pieces so they can work. And well, we believe, and this is something that is reasonably advanced because it has been very much favored by the recent model-based approaches based on telemetry.
Diego, we have still 3 minutes to go.
Yeah. It's this one and another one. When it comes to the action flow, things are a little bit more complicated because we have to suffer even more heterogeneity. And not only heterogeneity, but as well the multi-domain problem that is an issue as well when collecting data, but it's especially here because we're about to have a certain domain controlling what is offered in another domain. For this, and this is part of this project I'm mentioning here, the Inspire 5G+, we are in that case focused on security, but we believe that many of the results can be applied in other cases, is about, well, beyond the initial strategies related to domain-focused solutions or recommendation systems. The idea is having an SBA approach in which there is a federated approach for providing and consuming the different operations for control, and having some kind precisely of some kind of intelligence as well to announce and consume data. For this, we are working right now on a mouse wall, which is originally was something that we started for security evaluation. The idea is that we have been making it grow in something that is close to what we believe should eventually become a full digital twin for the network, though we still are working on it. We are relying very much on orchestration, on SDN, on model-based approach. So, but we, as I said, we are struggling right now with data ingestion on the one hand and how we apply direct control actions. Finally, as a summary, we believe that precisely one of the most important applications of AI networking would be precisely the idea of having digital twins that allow us to use it allow us to run experiments that make sense in the real network, and ideally try to apply directly these results of those experiments to the network, lowering the cost of optimization, making the assessment safer and cheaper for sure, and even applying to aspects like customizing whatever the training, natural or human or artificial. And what is important, let me say this, because for us, it's extremely important, is doing all of this, exposing all this data, using all this data, and relying on all this data while we are provide something that you can call top-grade anonymization or even complete anonymization, because data will be synthesized or data will be ultra-filtered without affecting the real effect. That's all from my side. Thank you so much.
Thank you very much, Diego. Very inspiring presentations. So we still have about 12 minutes to go before the end of the session. You just mentioned in your presentation, at the end of the presentation, Diego, the issue or the question of privacy. how do you see the importance of data protection by design and privacy by design in future research? In particular, what would be needed from a research infrastructure perspective to address it?
Well, what I think that this is essential, precisely the kind of insights and information that you can derive from in a research infrastructure, maybe even, I would say, more harmful than what you do in real life because of the laws of big numbers, etc., and the novel applications that you may have. As I said, for us, what we're trying to do with the mouse wheel is precisely try to avoid as much as possible the usage of real data. What we're trying to do is to learn what the real data from real people are and mimic them in a way in which we're not talking about, we're talking like someone that is behaving like you, but it's not you. And that's with all that this implies. And this is what I mentioned with the topmost anonymization.
Very interesting. Thomas, having the experience of an industrial leader in Europe, so addressing something which is, we're in a period of virtualization of the networks, virtualization of the infrastructure. At the same time, we still need to have hardware. What are, according to you, the main challenges to support the evolution of the industry, the hardware industry in Europe from a network technology perspective? Oh, your mic is muted, I think. Okay.
That's it's a normal mistake you are doing. I think now it's terrible. Maybe
on your side. Vanya?
Yes, sorry.
Could you switch off your mic, please?
Yes, sure.
The loop. I don't know what loudspeaker you're using. It's
to be honest, what is challenging us, you are thinking also the link between the physical world, where we are, let's say, strong inside in Europe, and to the virtual or new business world based on data, and when you're looking also how other partners are developing. You know, I'm not speaking about new business topics like Uber, Airbnb, and so on. You all know this. But the real topic is for us that we have, and I think Vanya mentioned this also, when you have a train or something else, or an infrastructure, something physical, what is the added value, what are the additional services, what's the data, how to exchange the data, how to get value out of the data, how to build up new business models. And now it's, I think Diego mentions this, when I got it correctly, how you interact in an ecosystem with whom, because then you are immediately coming in an other area, so that the train from provider A have to speak with the train from provider B and make it, and you have the customer, us, using the train. As a meaning, what I'm mentioning, we have, let's say, we are strong in the physical, trained also to supply products, solutions, and now we have to put on top the technology, that's the digitalization with AI, with a digital twin, like Diego mentioned. But then we have really to think what is the new ecosystem, what is the new business, what is the new services which are coming together. And here we have really to think about it. I can tell you, I'm just heading regarding, it's called IoT ecosystems, a project inside Siemens, exactly how the partner network, how the technology, and how all the business layer, the operation layer, and the technology layer fitting together. And that's, for my feeling, maybe I'm allowed to say this, when you compare us with US, maybe we have to be better trained in this area. Let's phrase it in this way. And now your mic is off. I think, Sebastian, your mic is off.
Now it's my mic, I'm sorry. Thank you very much. Vanya, from the evolution of network virtualization, we have dynamic network slicing, multi-tenant slices. How do you see the challenges from a cybersecurity and data protection perspective, so GDPR, personal data protection perspective, the research challenges ahead of us to address this complexity, this multi-layered embedding of slices into slices? How do you see it from Thales' perspective? What are the key challenges, according to you, from a research perspective?
So this is really the context we're looking at, that you very well summarized in terms of having these multi-tenant networks, but multi-domain networks. This is also a very important aspect that we want to look at. So we have this cybersecurity aspect, and I was talking about focusing on the run dimension of systems and infrastructure, and not just the build. I mean, cybersecurity is really where we want to. This is obvious, I would say, that we have to move in this direction. And in this domain, I think one of the difficult things is how what the role of AI and how we're going to take this into account. There are big questions about trusted AI components, responsible AI components. So this has to do with how we provide autonomy to some of the subsystems, and how we at the same time maintain the criticality or the business objectives that we want to provide. So that's really a key question. Building more trustworthy infrastructure. Trustworthy not just for the users, but the users can be industries. This is really a big challenge. And for the internet, it is, I think, a very deep research challenge, because internet was not designed with this goal in mind, and with the transformation that that has started with introduction of virtualization, there is a big opportunity to now address this today. But how to do this is still fairly open. I think I mentioned slices. This is just one first step. I think there are many more complex, different ways, combinations of different ways of doing that we should try and investigate in the future.
Very interesting. May I ask all of you, we still have 4 minutes. I'd like to give you the floor to each one of you. We're currently at a crossroad where we try to think and to reflect on what would be the requirement for future research infrastructures. And from your own perspective as industrial representatives, what would make sense? What would be if you would have 1 or 2 advice and recommendations to the research community on how to best address the need and best support the industry in your respective contexts and respective verticals? Who would like to start? Maybe just 1 or 2 key recommendations, and perhaps also some challenges we should focus on from a research perspective. Who would like to start? Diego, would you like to?
Sure. Well, for me, what is essential to take advantage of experimental facilities is precisely that we do that we support what has been always good science. I mean, that we are able to run experiments, understand experiments, repeat the experiments, variate the experiments to analyze the causes, collect data, analyze the data, because what is this is very much that is very much applicable not only for experimentation but as well for further testing when technologies move to the industry.
Very good, thank you very much. Thomas, would you like to share your views on this?
Yes, for sure. I think if you have seen in my presentation, we have this technology topic from let's say from the quantum computing up to the IDOT and the data and to the use cases. I think there are two aspects which I see, and see also responsibility bonus also in the industry, on the industry side, that we really provide use cases and make also on the one side a use case oriented topic, including also new business model. But testing, that's the one issue where we can really prove this together in sandboxes, in an environment but, and this is also important, this is somehow the balance, very well aware that also some kind of blue sky research is needed. But I think when we really bring the stakeholders, the collaborative together, from the blue sky research over the applied research about the use case driven research is the wrong word, but you know what I'm meaning, to the application. When we're looking at this, I think that would be great.
Yeah, very good. Thank you very much. Vanya, from your perspective, perhaps also on the issue of massive stakeholder integration or different users or end users integration, as you are actually in such a vertical.
What I think is really important for, if you think of a research in infrastructure, where you can test different protocols, different approaches. What I think is important is not just to offer this facility with the relevant key technology components. It's also to take into account that we're going to have to look at the run phase, which is produce data on the system. And I think as a community, other research communities are a bit more advanced because it was maybe more critical to them, like the language community. But I think, it's good to have the infrastructure, but it's also good to have the test data that comes with it. Ways to generate data, and a validated way to generate data, and else, I don't know, and then run some challenges and ask people to, researchers come and test their different solutions on so offer this as a service, I would say, to researchers that comes with infrastructure. That would be really very, very, very helpful also for the industry to have also, because it's also difficult in the industry to gather data. But if you have something that is referenced, that is shared by the community, this would, I've worked on data all my life, on network data all my life, and I know how much is helpful. And if we have one step further, that would be really great.
Excellent. Thank you very much, and I think that makes a direct connection, and we will end with this as we are running out of time. But I think the GaiaX initiatives that Thomas, you are leading, the research infrastructure such as slices and other initiatives, then could find ways to make data more interoperable, more accessible, and to enable to mutualize the knowledge and experimentation in a way to foster the development, research and innovation, if I understand well. So it will be a pleasure to collaborate with all of you. Thank you for your time and your excellent presentations. I wish you an excellent day.
Thanks. Have a nice day. See you. Bye-bye.
Thank you. Bye.
Thanks. Bye-bye.
Good morning, Lina.
Hi, and I have to open my laptop because that's where the camera is. I can hear you and I could see where my default browser is Edge, so that's why I have to search. Okay,
Yeah.
I can see that.
Try to share your screen. The best way to do it is to go to the sharing button that is at the bottom of your screen. And there you can share share your screen and go to application window.
Okay, I can see share a Google document, Figma, file, Miro, video, or PDF.
No, it's go to share screen. And when you go to share screen, choose application window. And choose the specific.
Very good. Okay, good. All right.
We have Arturo is still pending.
Sorry?
I'm waiting for Arturo.
Yeah, I have to also open my presentation.
Stavrula, can you hear me?
Yeah, now yes.
Okay.
Yeah.
Yes.
I thought that something happened.
I had to give permission. No, it was a problem. I had to give permission to the browser for the audio, and so I was just clicking on different places. Thank you very much.
So Lina, try to share your screen.
Yeah. Wait, I'm opening the.
If you have a problem, I have the representation. I can do it.
Yeah, it's just that I have to open it because I actually rebooted my computer because I have so many things open because I have a bit of network connectivity problem. So might be that at a certain point I have to switch off the video, but at least for the okay. Wait.
If you have many things open, I suggest you close Windows because many times they interfere with the application, and then you get glitches.
I try to close as many things as I can.
Okay, because it's something, yes.
Yeah.
Even if you have many tabs in the navigator window, if closing them usually helps because navigators are very heavy.
That's what I wanted to do. I have nothing open now, so okay, here we go.
Excellent. Go to presenters mode so to have the full screen of your presentation.
Yeah. I'll do that.
You have to do it at your application, yeah.
Yeah. All right, I can see it. I can't see myself anymore. I just see the slides as they are. I don't see much more, but it doesn't really matter. So.
Yes, I think this happens. Once you open your material, you cannot see yourself, I think.
Yeah, exactly.
Probably
it's just that I was just thinking in case, my network connectivity starts to go bonkers, I need to turn off the video at that point because we don't know why, but every now it's usually quite good, but then for some unexplicable reason.
You can use it as a PDF file.
Yeah, no, it's fine. It's fine. It's fine. I think I can switch between, so it's all right. It's
okay, no problem.
I can switch between the applications. I can be on a Chrome, and I can see, and then when I start sharing. So okay. So I have a few slides. I mean, I will also say in the beginning, obviously, the Slices project is from TD. It's from their portfolio. And they asked me to address this because you had also issues, that you wanted to link to the Connect activities. In my unit, we do Jean, we do, as you saw, Arturo. But I'll just give it's pretty high level overview, and then but I think it's probably better than to go down if there are some questions and so that the participants. I have the impression that 2 years ago I was invited to a conference in Paris or a workshop. Of the ICRI, this because I see some same names like Hakima, Chauchi, and all
yes,
this.
Esprit, yes,
exactly.
Esprit.
Yes,
yes, I was there.
And Exactly, and I have the impression that I was there because I remember this. I even saw this experimentation facility, and at that time it was sort of on. You know, at that time the discussion was about whether it should be a research infrastructure, and all this, and whether it should be on the S3 list. So okay, so I make the right connection there. So it's I remember that discussion and those people, and so I can make a little
yes,
bit. Okay, so it's
that is totally correct. Yes, that was when we submitted the proposal for the first time in S3. Proposals have a very, very long and very, very thorough evaluation process. Most of them are rejected at the first time, and some, not all, are approved at the second time. So we already submitted it for the first time. It was rejected, but with very good comments. If you get bad comments, it's better not to resubmit. So we got very good comments, very encouraging comments, and then we resubmitted. And now we are under the evaluation of the second proposal that, of course, this time we expect to get it approved because we fixed all the issues they told us. We have now many more member state support. So now we think really we will have this. And actually the moment is very good because with COVID and with the strategic fight between the US and China for 5G, I think Europe is perfectly aware that ICT is a sector where we need to keep a substantial presence. So I'm not talking to be self-autonomous or to do a monopoly or to be protectionist. But we have to remain competitive, and then we need definitely a research infrastructure because otherwise it's going to be very difficult.
The whole of the mantra of the current commission about the digital autonomy and strategic autonomy, if you want, and especially in digital field, is clearly, you know, our HPC program is of course geared to that. You know, before that we didn't have any supercomputers in Europe, and soon we'll have many. So you know, clearly these are the kind of considerations that we are all, or at the higher level, the Commission is very, very, very concerned about in a way. Of course, you have to keep the balance between competition and what is autonomy. So this is the of course the hard sort of line to especially when it comes to regulation. But this is more for the private sector. I think always in the research remit, it's sort of easier because you know usually the channels for researchers are a bit more restricted. So it's easier to justify things because it is for this kind of purpose. But yeah, exactly. Okay, good. But then my remark or my sort of recollection of the past is correct. That I was then, you know, at the time 2 years ago when I was there in Paris. So I remember that there was this discussion. I remember I was also shown there's like a sort of a lab, you know, with the physical, you know, really the experimentation facility which was there.
We invited you, and we invite you again now because we definitely need the support of your unit, and I will explain why. The point is that in S3, the environment is blue sky research, which is good. And I believe we should look into galaxies and know why galaxies collide. And I think we should look into the oceans and have oceanographic ships. And I think this is needed, definitely. But the problem is that in that environment, they feel quite reluctant when there is like a shorter term goal. I mean, they always ask for long-term goals, and having long-term goals is good. But having short-term goals is not bad. And in their environment, they seem to think that if you have a shorter-term goal in addition to a long-term goal, this is like negative. And our infrastructure will be, of course, scientific and will fit well in S3, but it's very, very related to DigiConnect. And we want an infrastructure that is not looking into galaxies only, it's looking into galaxies, but it's also solving the next generation of communications like 6G, which is a 10-year goal. But for them, a 10-year goal is very short term, believe it or not. Why? Because for them, 10 years sometimes is the time it takes to build the instrument. I mean, 10 years is when they build the actual facility, and then they start doing the research. So it's very important that you help us in conveying this view to DG Research and S3.
Yeah. Yes, I see. Obviously, from our DG Connect, all this. There are a lot of different units dealing with different things. This is not the ICT. The digital infrastructures are we as I said, we do resource infrastructures and the old infrastructures part of it.
Right.
Which obviously, is the first step, because this is the sort of the operating environment where we are. But then, of course, there's a lot of discussion that goes really at the high level, going, all these, all the digital infrastructure discussion in general in Europe, through Gaia-X and all these kind of things, and also the 3D, the different, 3G, 5G corridors and all this. So clearly, I'm not, that's not within my remit and within the remit of this unit. We do this, so I cannot really speak on behalf of everyone, but I can already give a sort of pointers to what we are doing and how the sort of the resource infrastructures landscape is evolving, also from the perspective of e-infrastructures, because clearly, of course, within this remit, this is still where you're operating, because you're still applying to be on the S3 list, etc. So this is obviously the primary sort of focus of your activities at the end. So
okay.
So
thank you very much for this support. Like I said, you are like a bridged unit, because you have contact with DG Research and you are obviously at DG Connect.
Yeah.
So it's already 11:50, so I would suggest we start.
Yeah,
I would please ask you to stick to the time, 20 minutes, and then you will have 15 minutes for your questions, because you are the only speaker in this session. Like I said, we consider your unit absolutely key for these initiatives, and therefore we wanted to highlight this. So please, I will start then the introduction, if you consider so, and we will start. Okay.
Yeah.
So
very good.
I hope all the attendees are back. It's already 11:50, so I hope everyone is back. So I will do the introduction of Lina Munari. So Lina Munari is the deputy head of unit at Unit C1, which is Open Science and Digital Modeling at the DG Connect in the European Commission. And Unit C1 has three main sectors, or three main goals. One is the European Open Science Cloud, and this is shared with DG Research and Technology Development, the ERTD. They also cover research and engineering networks and connectivity, which is mainly the GEAN network and the national networks, but not only. And then they have also a new flagship initiative funded from the digital program, which is Destination Earth, and I think it's most interesting. Lina has been working already at EU institutions for over 20 years, and the last 50 years he has been specifically at DG Connect, working on various sectors of technology research and innovation, such as digital libraries, digital preservation, learning technologies, and e-infrastructures. She has therefore an extremely relevant role as liaison between DG Connect and DG Research to make sure that the required synergies are maximized. So Lina, thank you very much for accepting. The floor is yours.
Thank you very much, Arturo, and good morning still from my side as well. And thank you for inviting me. I actually did a quick recap with Arturo. That 2 years ago, I was participating in a workshop organized by ICRI in Paris, and I was at time part of the discussions, or witnessing the discussions of this experimentation test facility proposal that was put on a list of ESPRI, but was not approved at that time. And I vividly remember those discussions, and also the facility that I was actually shown around. So this is a very nice sort of round to be back, and to first of all, of course, congratulate the team already for having managed to win the grant for this design study, and hopefully at the next stage towards being included on the list of ESPRI. So as I said, I'm from the DG Connect, from the Unit C1, where the main connection, of course, research infrastructures, that is the main part of the work program of Horizon Europe that we operate and we get our funding from. And that part is, of course, as you know, shared with the DG RTD. So that part funds all the research infrastructures activities. It funds EOSC activities, infrastructures, and including connectivity like GEAN. So So I hope that I can sort of live a little bit up to the expectations. Of course, you know, DG Connect does a lot of things in different areas of digital infrastructures. And also tries to link with initiatives up to the level of Gaia X, etc. You know, we have all our different units dealing with the various 5G, 3G, 6G corridors, etc. But okay, bringing the discussion back to really down to where we are now within the remit of research infrastructures. I'm happy to show you a little bit of the recent developments and maybe actually put back some questions to you on how you see yourselves developing in this framework. So the S3 landscape, this is actually at the kind of request to my colleagues from DG RTD. They provided me with this. Of course, you're probably much more knowledgeable about the research infrastructure landscape than we are at the DG Connect, as we know that we don't directly fund this. Of course, we interact with them and we see that our e-infrastructures that come from our portfolio are actually a research infrastructure as well, of course. So in previously, there's been sort of a bit more dichotomy between these. Of course, they are not completely glued together, but they become, and the aim is that the research infrastructures and the infrastructures will actually really come closer together, and the EOSC initiative or EOSC or sort of how you want to call it, it's a big thing. It's not a project, it's not an initiative, it's maybe nearly a mindset, you know, that we want to sort of how you want to describe it. So that's of course the most obvious part for these two to come together. So, you know, just as a reminder, of course, intergovernmental research infrastructures, those are the ones that are supported by the member states and well-established ones. Then you have the new pan-European research infrastructures, those listed on that S3 roadmap, and then we have networks of national research infrastructures. And these are the ones that are promoted through the projects supported by Horizon 2020 and in the new program Horizon Europe. So then an S3, of course, is an informal body, you know, it's providing advice to the council. Is also a platform for giving national authorities the opportunity to be informed and to explore international national initiatives of European significance, and incubator for new RIs, and in a way also European knowledge hub, which would set standards for roadmap methodology, policy analysis and advice, for example, in the area of COVID-19, which, as we know, is still the sort of the name of the game today. Yeah, you know, we've been looking, you know, it's a year, more than a year now that we're actually fully aware of what this means, and unfortunately we haven't, you know, come over. But I mean, in a way, the COVID-19 pandemics, if you try to find, of course, good things about it, which is quite hard, but at least it has brought very quickly also different research infrastructures and see our scientists together, global, but also European level, trying to really also, you know, address those issues that have been on the table for a long time, but now we start to realizing what does it mean, not having open access to data, not having access to those, let's say, even at the metadata, you know, classification level, that we having issues in combining data and actually really making meaningful analysis in quick time when we need to. So the mandates, this is what the council mandates we established already in 2002 is. What are the S3s? They support this coherent strategy-led approach, facilitate multilateral initiative, would establish a European roadmap for research infrastructures, and then to ensure the follow-up of the implementation. So so just in general, to remind you of what is the landscape
Lina,
we are evolving in. Yes?
Lina, may I interrupt you a second?
Yes.
I'm afraid you are passing slides, right? One after the other.
Yeah.
I'm afraid you have like two screens set up. So the screen that we see is the PowerPoint for editing the slides.
The next slide, yeah.
And we do not see the other PowerPoint. So we are only seeing the first slide. So I think it's a two-screen problem.
Okay.
So I think we should try to fix this. We should try to. In PowerPoint, you can select that it has only one like view, not two views.
Would this be better? Is this better?
No.
No.
Okay. If you would like,
no,
it's fine. Now it's fine.
Just a second ago, you did it.
Okay, I did it. Okay. Very good. Okay, because maybe it was just a bit slow to respond. Wait a second. There we go. I do display settings, swap presenter view and slideshow. Okay.
That's it.
Yes?
Not yet. Wait, let's wait a second. Let's wait a second, but not yet. No, maybe what we could do, Lina, is just use this view and just pass the slides in the editing view of PowerPoint instead of trying to go full screen, because I think it will not work. So if in this view you just switch to the next slide by clicking on it, and we should see it. If you click on slide number 5 just to check.
Yeah, wait a second. If I click on slide number 5.
Yes, yes, it switches. So let's use this view. It's a little small, but we can see it properly. So sorry for the interruption.
Okay, all right. So I can see there's a discrepancy between the. All right, fine. I tried to. Thanks for letting me know. I tried to make it a bit bigger here. Well, it becomes too big for the screen. But okay, I will share the slides. I'm sorry for this because I was expecting some sort of an issue as always. So I hope that is it enough for you to see, because I have slides that are actually even worse.
No, it is fine because your slides have large font. Thank you.
Okay, good. All right. Sorry for that. So, I mean, of course, I mean, I spoke a little bit over those slides, but as I said in the beginning, you are probably more knowledgeable about, all the details about the S3 landscape as it is now. I just wanted to give them as a pointer, because as sort of a startup of where I want to go next. So therefore, I mean, I won't go back to those slides now, obviously. Yeah? So it's all right. So
just go ahead. Yes.
Yes, exactly. So, okay, now you can see the S3 roadmap slide, yes?
Yes, no, it's fine, thank you.
Okay, fine, good. So, okay, so if you look at the cycles of the S3 roadmaps, the first one was published in 2006, updated subsequently every 2 years, and identified 48 projects to foster European leadership across these scientific fields. And it was a major financial investment. So about 20 billion. Our long-term commitment for operation was 2 billion a year. So then, of course, we look at the roadmap cycle as it continues more in detail. So you had, the different landmarks, you had the different project, and you had the landscape analysis. And as you know, there's an update now coming in 21. So this is just to give a bit of a pointers for the background. All right. So now it's getting a bit harder, but maybe since everybody's in front of their screen and not in an audience, in an auditorium, you can actually you can probably go much closer to the screen to see what is there. Here, I just wanted to highlight obviously the different kind of the projects and the landmarks that we are currently funding. And as you know, that within the digit field, there's currently praise. And I know that Slices is very much trying to make the case for being including on that list. Of course, at this point, when these evaluations and these are ongoing, we don't comment on these proposals. But to say that, of course, to the point that when the proposal is justified and whether there's a clear need from the scientific community, this is of course the criteria for considering new proposals. So just to make a little also an overview of, of course we have the ICT based and S3s and those that support ICT research. So clearly Slices is in the area of those really supporting the ICT research rather than having an ICT as a main component. We from the DG Connect, we sort of tend to look at the world through technology glasses always. So which is even surprising for us that when we sometimes go to other policy DGs, we see that, the way we see any policy evolving, we see that there's always, of course, especially these days, I mean, look back 20 years, these whole technologies were not so pervasive as they are now. So clearly for us, any activity, whether it's scientific or non-scientific, it would need to have an ICT component, because otherwise this is not anymore the world that we operate in these days. And we know that the technology research can support very much the different workflows of the scientists, and more research there is into it. Clearly, it's a very important thing, because and especially in this sort of larger horizontal way of approaching the ICT research as a target area rather than an application area. So here you see obviously those S3s that you're already quite knowledgeable about, of course, also in different thematic areas that we from the infrastructures perspective see as sort of obviously the let's see the food for the technologies that we built. If within the area of the infrastructures that are providing the services for the researchers and are doing a lot of work in the area of data infrastructures and having providing the best sort of possible conditions for the researchers to work on. We know, of course, that within the different S3s, they are sort of a little bit of like these private gardens as well. The researchers, of course, have the most appropriate and maybe up to bespoke kind of tools and services that serve that community. And it's sometimes hard to see beyond and saying like, why would we actually need to share, because we have everything we need in this community and in this sort of our private remit, if you want to talk it as I say private between brackets, sort of within the research infrastructures. But then of course there's a whole lot of researchers who not necessarily have access to those facilities, and there's a lot of there can be the application, but there can also be some sort of economies of scale that can be won if in case actually we do open up and we actually optimize those resources that we have at the use in Europe. Of course, I am of course very aware of the fact that most of the research infrastructures are funded from the national budget, so it's the big part of it. So we at Europe are providing just a sort of a topper to that, but of course that's an important topper because that is exactly looking for those connections and trying to make sort of best out of the synergies that sort of Europe has to offer, if you want to look at it the bigger European rather than national scheme. All right, so the infra landscape then, which is of course very much our own world. We have, this is a very bad slide now to show in this mode, but what I want to highlight, probably what I can do, is there is a part that I really wanted to highlight, which is not going off, but I can highlight it this way as well. So I wanted to show with this slides actually the sort of an overview of what we have been funding in EOSC for the entire Horizon 2020. Okay, I leave these slides behind so you can go and look at details. The highlight, what I wanted to do here is that, of course, many S3 clusters now are also being funded from our EOSC programs, as you know. Those related to, you can see here, the MREFAIR, the SSHOA, OC, Escape, EOSC Live, those are all part of those S3 clusters, as we call them, that we are trying to sort of facilitate the integration into the larger EOSC landscape. And as you know, that is quite a complicated landscape. It doesn't only involve the infrastructures, but it involves a lot of other doers and also a lot of policies that are at the crossroads of these activities. So just to give you a little pointer from our perspective, as was said in the beginning, the research infrastructures work program, the EOSC part there, whether it was called in the past e-infrastructures, and now it was always labeled as EOSC infra calls or infra EOSC calls, sorry. So the last round, which we closed now last year, and this final input of around 65 million, which goes into funding the EOSC sort of service offering and the overall portal or the platform. This is the outcomes. I mean, you might also already be aware of course, what is the final outcome. So there is the big part, the biggest call, and or the biggest part of this call was this single project that we were looking for under the Infra EOSCA 03. Aiming to find integration and consolidation of the existing pan-European access mechanism for public research infrastructures and commercial services through EOSC portal. So it's a little bit the follow-up to the project that we funded in the last cycle called EOSC Hub, which is coming to an end. But of course, consolidating this into a much larger and much more sort of homogeneous, we would like to say, approach. But of course, understanding still that in this call, you know, there are, if there were 70 partners in EOSC Hub project, here the project that was selected, which is still kind of currently under negotiation, EOSC Future, is still having a large number of partners, also including research infrastructures, to the extent that that was sort of possible at this point, in order to really provide those links on and those sort of openings for these science clusters and science sort of projects that can be sort of catalyst for further integration, or at least federation and a sort of cross-use in European level of those services that are being offered. The others, the Infra Zero call was the one that was actually addressing the service provision as such. And through that we also fund the access. So we are using the virtual access provision in order to be able to, for those beneficiaries, to be able to claim back the costs that they actually subdue due to the fact that they're offering these services beyond their initial communities. So this is the sort of in a nutshell the approach that we've taken in Horizon 2020. And to close the EOSC Infra EOSC call cycle, those 5 projects that are there, EGIA, STICE, Open Air Nexus, and C-Scale Reliance, are the projects that got selected. And you see there also the topics that were actually, there was a above the net network, above the net services was one of the.
I'm sorry to interrupt, Lina, sorry, but we are already out of time. So I would please ask you to try to summarize or converge.
Yeah, sure. I wasn't really sure. Yeah, exactly. Yeah, very good. So, so just to summarize, this is what we're going for in Horizon Europe, in Pillar 1. As you see, you know, we have a one destination which is focusing on EOSC, is continuing the activities in that field, and destination 5, which is on network connectivity, which is on GEAN and the connectivity as we've been doing in the previous one. And as you see there as well, you know, the research infrastructures support is coming from the other destinations, but with the linkage whenever we need to the other parts. Okay, with all these technical problems and things, I might want to go quickly, because what I wanted to also showcase a little bit, you know, you've been aware of how EOSC has developed in the recent 2 years. You know, we have a whole partnership agreement that we have now we are signing with the EOSC Association and all those who have signed up with it. And just to say, like, in the future, the EOSC related activities and work programs will be funded through consulting this EOSC partnership, and the priorities are set also in this research and innovation agenda, which was developed over the last 2 years by the interim governance. And this is actually the point where I wanted to get to, because I mean, if you look at the action areas now, where the research infrastructures or the strategic research and innovation agenda is actually focusing on, I would like to hear also from your side of where do you see yourselves, you know, considering if slices, whether it is or not going to be in the next S3 list, where do you see yourself as your best input? And this is it would be interesting to hear from you, looking at the landscape of S3s, looking at the landscape of infrastructures, and looking at the future, how EOSC actually is going to evolve around sort of a core, which is more of a loose, but you know, linked to identifiers, metadata, fair metrics, and AI, and we go further to the resource layers, which are more the service offering, etc., which are more on the outside of the really the EOS core. So I would like to hear from you as well how you see yourselves situated in this landscape, and probably what you would like us to take into account when we move ahead with this, because of course the research that is going to be done under this remit is very important for us, because we are still developing and funding projects and technology also in order to be able to sort of provide the best EOS environment for the researchers in Europe. So I would like to hear also from you, what is your views? So I step these other slides, and I would like to leave you with this challenge as a thought, saying that, however, while instrumented, interconnected, and intelligent world has unprecedented potential to solve the key challenge of the time, the potential will only be realized if the research infrastructures are evolving to allow scientists to make the best use of their information. So sorry for that. I'm 4 minutes over time, and I hope that I can actually now connect back also in the meeting rather than looking at my slides, so that I can take some questions if there are. Thank you very much.
Okay, thank you very much. We'll have some claps because it's a pity not to have claps. So thank you very much, Lina. I would like to start addressing your question. You asked us a question on your turn, and I would like to share my screen a second to be able to address your question, which is let me check. I tried it formerly and it failed, so now it's not working. Just give me a second. Okay, let's see if it works. Can you see my screen? Can you see a slide in my screen?
Yes, if you want to make it a little bigger, yes.
Can you maybe bigger also?
Yeah, no, I can see, sure, yeah. Okay,
good. So this is basically our point. This table contains the current S3 infrastructures called landmarks by working group. They group them into fields of research. So they have an energy field with infrastructures to research on energy, an environment, one on health and food, one on physical sciences and engineering, and one on social and cultural innovation. And all of these indicate the target of the research. Now, S3 added one new field, which is called data computing and digital, okay, which is this last one. But we don't agree because they placed praise here, because praise is using ICT technology, but it's not designed for research on ICT as the main goal. It's mainly thematic. Of course, ICT is another theme. It's not forbidden to research in ICT with praise, but it's not its main goal. So on our view, S3 could have a category called multidisciplinary or horizontal or whatever you want. And there we could put infrastructures such as praise or GEANT or EOS, which are totally horizontal for many research fields. On our view, currently, S3 has 0 infrastructures to research on ICT, 0. So on our view, this is something we should fix. So how do we see fitting? So we see ourselves fitting in the data computing and digital infrastructures as a thematic objective, being the first one, while praise, EOS, or GEANT are horizontal research infrastructures. Does this address your question?
Yes, indeed, and I see this, and this is also the way I see it. At least, like, of course, we have all the existing research infrastructures, infrastructures. We have all these new platforms and environments that are being created, but whether we actually really do research on those components and to what extent and at European level, clearly I see this connection. But I would like to also see from the practical point of view of like, provided that this research infrastructure was accepted on the S3 list. So what would be your concrete contribution? I mean, you know, for example, for EOSC or for the European research community in general. So if you look all these S3s, clearly they use technology, they use research infrastructure, digital infrastructures within the work. You know, this is, you know, this cross, you know, they have access to high performance computing, they have access to different data infrastructures. So how do you see then concretely this research infrastructure within this remit contributing to this maybe a bit more sort of application, close to application of application field, you know, activities that we are funding? So research per se, yes, but I mean, how would you see it as sort of the concrete links to EOSC community, to different other S3s that probably would be served by this?
Okay, so first of all, since we are a focused and thematic infrastructure, we are reaching for the European community on the field. So we will be supporting all researchers in industry and academia doing ICT research throughout Europe, same as telescopes are intended to help astronomers or astrophysicists. So our main goal is to do a focused research. And of course, we also want to reach out and collaborate with other fields, because ICT relates a lot with bio, relates a lot sometimes with energy, relates a lot with other fields. And this is where EOSC definitely plays a role, because we plan a very important part of the slices proposal is on open science and open data. So we definitely want to put all the results arising from slices in the open in EOSC and in other repositories, so other fields, not only the ICT field as a whole benefits from reaching that information, but other fields that are related to or borderline with ICT. So definitely to us, EOSC in particular is an absolutely key element to disseminate and multiply the impact of our results arising from slices. Another important element is GEANT, of course, because many of the facilities will be remotely accessed, because slices is not a single-sited facility, it's a distributed facility. So we will provide remote access. So GEANT will be essential to be able to provide remote access to the labs, to this network of labs. And this is the way we will be able to offer our services to the broader community outside of our own, so to say, specific field. So definitely it's very important to us to reach out and to collaborate, but we do not hide that we are not a horizontal research facility. We are a facility focused on ICT, the first one, hopefully.
Okay, very good. And also, I would like to know if you already have some contacts, like, for example, with the EOSC Association or the main. I might suspect that there are some, you know, overlapping beneficiaries between different projects, etc. But are you already in contact with any of the key projects that are currently being funded under EOSC? And to see, you know, to what extent, because these are research and innovation actions in principle, yes, even though they are a bit of a different animal in the pillar one.
If you allow me a second, I would not like to monopolize this between the dialogue between you and me. I have some questions on the chat of questions. If you allow me, I can read it so other people can participate. Yeah, is this okay with you? Okay. So I have I have a comment by John Ott, which is more a comment than a question. He says, I appreciate the many important and highly relevant application areas in S3, but I am missing true networking and network research. We will need a network infrastructure also in the future, so he basically is insisting on this. But Christian has a question. Christian says, could you comment on the current vision of EOSC on the long-term preservation of data? Who is going to be responsible for it, in particular after the end of the project? This is a question by Christian.
Yeah, the long-term preservation of the data, clearly, as you know, the data per se is not is kept, it's generated, it's curated, and it's stored in short term and in long term in those facilities who actually created it. So the repositories are currently still, and it makes sense because the larger the amount of data, it becomes very complicated and costly and even impossible to start moving data around. So the approach is, of course, that the services and the users would go to the data rather than the data moving around. And this, of course, then says as well, whose responsibility is then the long-term preservation. There are some approaches that actually there are some discussions, and maybe there might be in the future some initiatives to fund some sort of central repository as well at the EU level of certain level of open data. To what extent, what is really the remit and the scope of it, and whether actually it's really responding to those critical questions of the long-term preservation, because of course I know that these are different questions than the preservation or storage in general, because there are different levels. So in the unit we are also funding one project called Archiver, which is about it's a pre-commercial procurement for looking for long-term preservation solutions, actually as further RTD for it in the field of research and infrastructures. But further than that, I know from my past when I used to work with digital preservation, that was 7 years ago, that the problem can be described as humongous. I remember always at that time that I was, it was presented like what we know now, or what we need to preserve is just the tip of the iceberg, but actually the major part of the iceberg is under the water. So, whether those selection and sort of automation of the preservation, but also what needs to be preserved is of course still probably a question that needs to be solved, because that always adds up to the volume of the data that needs to be preserved. But at the European level, so this is currently still the approach. I know that particularly from the DGRTD side, they're looking at facilitating this open report will be actually more central, probably also with the experience that we've had this year on COVID related data, which is residing in all different silos. So, but further than that, I mean, obviously, I don't have a full-time solution for that to provide at this point.
Okay, thank you very much for your question. So there is another question by Judy. Judy says, regarding contact with EOSC since mid-2020, all attempts to contact with EOSC in face of EOSC Secretariat were unsuccessful. Is it only for national representatives, or in what way could we reach out and have some contact with EOSC? Because our former attempts up to now have not been successful. Could you give us some guidance?
Yes, sure. I mean, as I explained, the last 2 years of EOSC sort of governance, because before we didn't have any governance. It was just a scattered project. There might have been, volume in terms of funding was probably not insignificant, but there was not an overall sort of governance around this sort of individual projects. And the last 2 years, up until the end of last year, the EOSC Secretariat was the project that was actually supporting this governance structure that was set up for 2 years. Then there were three-partite governance. One formed of member states, the governance board, the other one, the executive board, that was the one which is doing sort of a lot of this domain expertise work and all those publications that you can also see most of them on the site. And finally, the stakeholder forums, which were the bigger stakeholder events. So I do understand, and I actually feel, that there was a little bit of this feeling that there's a lot of things going on, but we are not being heard, or we are not being involved, and I think it was probably at that time more of a practical thing, because in all those stakeholder forums and those bigger events that were organized were actually the stakeholder events, and sort of the boards were trying to sort of represent the communities in order to really have there was, and there were many consultations as well on the documents, as you know, the 3 has been put up for consultation, etc. So try to be, or the community tried to be as open as possible. Now, as of this year, the game has changed clearly, as I explained, that now the association which has been formed, for which you can join. I think there are already at the first assembly, there were some 100 members who had joined. So this is now the new sort of, if you want to say, the structured dialogue partner of the Commission when it comes to funding EOSC-related activities and the research priorities. So that's why it's sort of quite important to sort of be because the way the Commission works, we always look at the stakeholders of what are their inputs, and sort of we can channel that to the program committee and to the proposals and to the work program drafts that we put. So in the future, the work program drafts will be based a lot on what we get from the EOSC Association, through the partnership, the formal partnership that we are establishing now. So there's going to be formal partnership to manage the EOSC partnership. You've seen the proposal as well online. And the dialogue will go that. So, I mean, it's still a co-program partnership. It's not like in Euro-HPC, which is institutionalized. It's co-program means that we program the activities more formally together. But this is really the modus operandum for the next 7 years for this framework program. So within the institutions or the players that are involved here today, I mean, I'm sure there is a sort of whole new set of governance being set up also for the association. Their directorship is being established, etc. And plus, the membership, which is open. Is really the sort of way to structurally participate in the dialogue. That said, I'm sure that the next iterations of SRIA, for example, because of course it cannot be fixed. Research strategic research agenda cannot be fixed for 7 years. It has to evolve. So I'm pretty sure that this SRIA, the next iterations that it goes through, it will still go beyond that for wider consultation. But the idea is to structure the community and the sort of the dialogue that we have through the association, which is probably not yet ideal, but it's better than before, as in a way, because before it was like the community is very big, so it's hard to. So this is our approach to that. And as you know, there are a lot of other partnerships. There's 48 partnerships that have been proposed for Horizon Europe. So EOSC being actually the only horizontal one, sort of cross-sectoral one, so in a way. But this is probably involving if I hope that this clarifies a bit how the work is organized for the next funding period.
Okay, thank you very much. It was very clear and detailed answer, and you can count on our side to be totally aligned with EOSC and to be participating into it. I have another question from Peter. Peter says, EOSC is about the integration of existing well-developed IT technologies and providing infrastructure based on those existing technologies for non-IT scientists. But who provides infrastructure for IT scientists if they want to develop 6G and other future IT technology? This is the question that is being posed.
Maybe that's you then. So maybe that's what I'm saying. So it's within the remit of EOSC. It's taken a long time. It's taken 2 years for the interim governments actually to define what is EOSC, and the definition is probably not yet perfect, but it's also more clear than it was 2 years ago. Let's face it. Let's do baby steps here, and the rest. I mean, who will provide support for the ICT research? I mean, through the approach, I think the kind of the slices approach that you're taking here, I think it's probably. This is why we cater for different communities and different sort of needs. I think as you position yourself with like a vertical infrastructure, research infrastructure that can serve then of course horizontally, I think is probably, I mean, with my little bit totally layman approach and this way, other than, but I mean, of course, what I always say as well is that the Commission is very open for ideas. I mean, we if there are ideas, if there are sort of considerations, we are always, talking to stakeholders. So if there are more specific proposals that you think, because often the stakeholders see better from outside what the entire Connect or entire department will be doing, and say like, if we see these things happening in different areas, don't you think that this would be a good to put this? So if you have these kind of concrete proposals or ideas, we're of course always open to discuss. whether everything then goes up to the operational level, and that's different. But I mean, I would like to reiterate that the Commission is a very open organization, as we serve the stakeholders in the European interest. So this is, if you have further suggestions, we are of course happy to hear.
No, we are absolutely happy with Commission support, and we definitely acknowledge that it's open. Actually, we received, the Slices community has received 2 projects approved, one from the infra call and another one from the supporting call. And we have 2 research and innovation actions to support the activity of building slices or explaining the slices initiative. So we are very grateful, and we acknowledge of this openness, that the Commission listened to our, so to say, activities and our proactive steps towards this. But now, of course, the key issue is the slices evaluation. This is where we are really focusing our efforts, and where we are really worried, and not worried, but safe to say, paying attention to the S3 evaluation. It's a very long and detailed process, and we hope that DG Connect also could express their interest in such an infrastructure. Okay, so there are no more questions on the time being. So I will answer the one you gave me, which is how do we plan to relate or to integrate with existing EOS projects. And what we are aiming to is, first of all, have our own thematic project. Like many of them, you have Eneas for astronomy, or Sineca for genomic, and you have projects for energy. So first of all, to have our own specific project for ICT data coming out of slices. So this would be one way of liaising with EOSC. And the other way would be contributing to the horizontal ones, because we are ICT. So we can help in projects such as Archiver or Extreme Data Cloud, because we are also experts in ICT, and we can contribute to horizontal EOS projects aiming to improve and enlarge and make more efficient EOSC itself. So definitely we would be able to collaborate in EOS projects in these 2 ways. So this would be my answer to the question you asked. I don't see any more questions in the chat, but maybe anybody would like to ask a question speaking, maybe Serge or Stabrula or anybody else. Otherwise, we could close the session. So unless I see any further question, or of course, you, Lina, have any further question, that also you can ask questions. No more questions from the audience. I don't see any questions in the chat. In the questions tab, I mean. No. Any questions? Stabrula, would you like to have any question, maybe?
No, thank you.
Thank you. Lina, any last question on your side?
No. I see there is a comment from Sebastian that the slides is addressing the display priorities. May be interesting to display the slide and discuss the contribution of slices. So that would be very useful, because I do see actually that slices could be sort of a glue between, the infrastructures and, horizontally and vertically. So it would be nice to have sort of a nice position statement from you. How do you think you could actually concretely contribute to these objectives? So it's always easier than to connect the dots when we have this kind of position papers, but at least some positions of the community of how you think that what is your contribution. So we would be very happy to have that.
Okay, Sebastian is typing, so maybe he's refining his question. It's in the chat, not in the questions. So maybe we could see what he's. Okay, so basically he says we can continue refining. Okay, thank you very much, Sebastian. Good. Then we don't have any further questions or comments on the chat. So I thank you very much, Lina, honestly, for participating in this, and we acknowledge very much the support of DG Connect, and let's continue talking. So
definitely, yes. Thanks for inviting us, and have a very nice rest of the event.
Thank you. I pass the token. Thank you very much. I pass the token to Stabrula.
Hello, everybody. Can you hear me?
Yes, you can hear you. Excellent.
Excellent. Okay. Okay. It's a great pleasure for me to close the session and close the day 2. Let me just present a couple of slides I prepared as a roundup for day 2. So I'm Bartosz Belter from Poznan Supercomputing and Networking Center. It's a great pleasure for me to close this day 2. We have very distinguished speakers, and we learned a lot from these communities around slices, from scientific community, from industry, and last but not least, a very important aspect of the support of the European Commission for potential activities within slices. So I will go briefly about findings of the today's meeting, and then I will hand over to Serge. So probably Serge would like to close the whole workshop as the coordinator of slices. I hope you can see the slides. Just a couple of slides. I don't want to repeat information you already provided, but it's very important for us to make notes of the key messages you passed in your presentations. So we discussed today 3 themes: the scientific challenges, industrial perspectives, and potential catalysts for slices from the EC perspective. Let me start with scientific challenges. So we had an interesting talk from Finland, from the speaker from Finland, and he explained his vision for 2030. Our community will be data-driven and with limited access to wireless connectivity. So the important conclusion from this is that wireless connectivity is driving major societal challenges. This is very important, and I believe slices positions very well ourselves regarding these technologies. What is worth to mention that Finland runs the world's first 6G research program with ambitious goals and program, and this is really something we should follow as Europe and as individual countries. And last but not least, we heard about drivers. What are the critical drivers towards beyond 5G technologies? So we listen about societal challenges, business challenges, security, radio technologies, and AI standards. The next speaker talked about a slightly different subject. It was a user-centric internet. So we were listening to the talk about responsible internet to increase trust. So what's it all about? It's all about data and data transparency, accountability, and controllability. Sorry. So we are flooded with data. It's data about people and research data. We need to make sure that we are able to control this data, manage this data, and provide trusted services for citizens. That's why we need research infrastructures to experiment with this. Next, the next speaker was talking about testbeds, and he gave us a set of advanced advices how to build advanced future ICT testbeds, and he mentioned 2 important aspects about scaling the testbeds and sharing the testbeds. So these are 2 different but very important elements of building the research infrastructure. You need to consider how you scale up individual testbeds as we plan in slices to a single unified organism. And you need to think how to share the testbeds with all the automation and documentation. You need to identify the target audience for the infrastructure. We heard about some challenges from the practical and scientific point of view. And these are very important and very to the point regarding slices. So this closed the session on scientific challenges, and then we had a session from industry, and we heard about several talks about industrial perspectives for research infrastructures. So we start with a network vendor. So the network automation and autonomous networking is a key topic. And here, network AI is in the spotlight. So we heard about two interesting points on this subject. What network can do for artificial intelligence, and what artificial intelligence can do for networking. And that was really interesting to listen. The second talk was from manufacturing industry. And here we heard about opportunities from data and AI perspective. And the key message is that AI and robotics are key enablers for innovation in manufacturing industry. So we were seeing on the screen information about self-operation, self-adaptation based on data. And the ultimate vision presented was that self-X is provided without detailed programming or engineering and without human supervision. And this is a very ambitious goal, which can be realized, of course, by industry, but we believe that it can be realized also with support from scientific community, with research infrastructures and scientists working together with industry on these topics. Also, there was mentioning of Gaia-X as a federated data infrastructure for Europe, and this is very important for slices itself, because we believe there is a strong potential for liaising with Gaia-X and slices. We have similar goals, different actors involved, different stakeholders, but we are building a federated infrastructure. And data infrastructure, as we heard, is a very important element of research infrastructures. Next, we heard about perspective from technology supplier, service provider, and the system integrator. So from their perspective, 5G is a game changer. And that was not the case for 4G. And while integrators are delivering solutions to different vertical markets, vertical end-to-end slicing is a key. And again, from the slices point of view, this is very timely and reasonable to get involved, as we are aiming at providing end-to-end slicing across different heterogeneous technologies. What we learned also today from the speaker is that they are looking for new research and testing methods. So methods from build to run, and this is a game changer for the company as well. So from build to run, so they are looking for solutions to be able to evaluate, compose, and monitor solutions which are ready to the market. And on the other hand, they are looking for testing methods for elitists. So they look for research in critical cyber-secure resilience of services and the infrastructure. The next speaker, Diego from the network operator, he presented the network operator perspective. And there was a key message from the slides, from the talk, that we are living in the replication, we need replication in digital era. And this is related to twinning the networks. So networks are by design complex and difficult for making digital twins. And there are different aspects why networks are so complex and difficult to map. You need to take into account differential facts for the network. So topology and geometry awareness, the conservation principle, openness. We've all heard about this from the talk. We need to deal with heterogeneity at all levels, at sources, consumers, models, resources, supporting infrastructures. And the message is that twinning the networks, digital twins, are essential tools for harnessing AI in the networks. At the end of the session, we had a discussion with speakers, and we captured some recommendations and conclusions from industry with regards to the research infrastructures. And the key messages we captured is, first, allow repeatability of experiments. So this is a very important element for industry. So they would like to repeat experiments with different conditions, but with the same, with exactly the same network conditions, so they can measure measure and compare applications in a stable environment. We need to ensure that data is collected for further analysis. We need to keep in mind that industry can provide us with use cases and new business models for further validation in research infrastructures. So we need to keep in mind there is a blue sky research, which is very much preferred by the scientific community, and applied science, which is needed by the industry. There was also a mentioning about data. Research infrastructure should not only offer technology, but also should be capable of providing data from ongoing and past experiments. And we were advised to provide a service, experimental data as a service. This might be an important element, and we should consider this in our work. And the last session we had today was from the EC perspective, potential catalyst for slices. So we're listening about European research infrastructure landscape. We were listening about EOSC, which is very important initiative in Europe. We are also given with the SV roadmap and the numbers of projects in different domains. As it was mentioned, in digit domain, we have only one research infrastructure, but it should be noted that there are other research infrastructures in other domains which are ICT based. An example in environment or societal research. It was mentioned Daria, Eric, Clarin, and other research infrastructures. So possibly some collaboration between these research infrastructures are also necessary. We were given with some opportunities for slices within EOSC, also short-term, the H2020 calls, and also with some destinations within Horizon Europe. And last but not least, we were given a challenge to all of us that we need to follow and evolve our research infrastructures to make the best use of the available information to our users and scientists. At the end, I would like to remind you about what Slices is about. So Slices is a scientific instrument designed to support large-scale experimental ICT research. So from our point of view, it's a programmable platform. And the network infrastructure and services within Slices are seen as networked software, not just a set of network protocols. So this is the fundamental change how we see Slices comparing to other testbeds. So I would like to thank you for joining the day 2. As I was instructed, you may watch recordings from this workshop on our website soon. Don't forget to go for the website. And that's all from my side. I would like to hand over now to the coordinator of the project, to Serge.
Hi to everyone. Nice to see you again. So we hope that you enjoy the workshop as the 130 single participants. At the first Slices workshop, we didn't really advertise broadly, but we are happy to observe that this has a value for the community. And I would like to stress the fact that although this workshop and those activities are organized by a EU-funded project, that Slices is actually not bonded to a project. It's really an open and inclusive community initiative. So back to Lina's comments, we of course applaud the existence of e-infrastructures as a support of e-science and important scientific domains, but we are not one. We clearly position ourselves as a scientific instrument for the research community in digital sciences and infrastructures on its own. This is exactly what was stressed by Bartek. And of course, as such, we are willing to contribute to EOSC and S3 as any other scientific instrument. So I would like to close by thanks to all speakers and participants for your valuable contribution and interest. We, of course, invite you to join and participate to the Slices effort and monitor our activities through our website and social media. So again, do not hesitate to contact us, and we'll be very happy to see how we can include you in the development of Slices. So this is a long journey. We started back in 2017 just to speak about Slices. And of course, we need your guidance and support by all means. So I would like to close by expressing our gratitude to all those who contributed to make this event come true. So thanks to everyone. Again, this virtual format is a little bit peculiar because, as you have seen, we have to be very strict on timing. But I hope that you really enjoyed, and in case it was a bit too fast, you can replay, watch it again. And please do not hesitate to liaise with us. We'll be very happy to engage into a discussion. Thanks to everyone. We are right on time, 4 minutes before the deadline. And take good care of you and enjoy your day. Bye-bye.